Attention Earthlings! Yes, that would include you. Scientists have discovered a new member of the solar system. We officially have a new dwarf planet orbiting well beyond Neptune. But that's not all. Despite being small and unremarkable, this object, called 2017 OF201, I know it's a goofy name, might hold the key information about the speculated existence of Planet 9. Or, better said, it spoils the fun because instead of helping us find Planet 9, it could be the first tangible evidence that the theoretical ninth major planet was just that, a theory. But first, what exactly are dwarf planets? And why is this discovery so important? Well, in the early 21st century, researchers gained better telescopes and began discovering smaller, weirder celestial objects. It started with Eris in 2003, but the discovery of additional similar bodies led to Pluto losing its status as a quote, true planet. To proudly carry the name of a planet, a space rock must check off 3 boxes. It must orbit the Sun, not another planet, like a moon would. It must be massive enough for its gravity to make it round. And it needs to be gravitationally dominant in its orbit. In other words, an object should be able to clear out most other objects in its path by absorbing them, slinging them away, or influencing them in some other way, like paying them off. Hey, just kidding. Imagine a giant, powerful truck driving in its own lane, pushing smaller cars aside. Hey, sounds like my commute. Although Pluto is orbiting the Sun and has the needed elliptical appearance, it's in the Kuiper belt, a region full of icy objects. Because it can't clear its orbit, researchers realized that Pluto was not that different from many other similar bodies known as trans-Neptunian objects or TNOs. There are well over 5,000 known TNOs out there, with only 1,000 being officially numbered, meaning they've been studied enough to have their orbits confirmed. Now here's where it gets interesting. A while ago, scientists noted a pattern. Many of these minor planets shared similar paths and tilts. This inspired a theory that those objects were influenced by some still undiscovered Planet 9, also known as Planet X. The proposed super-Earth would have a mass 5 to 10 times greater than Earth's. It would orbit far on the outskirts, possibly as far as 500 astronomical units, and like an invisible puppeteer, manipulate the orbits of TNOs with its gravity. Some of these objects get classified as extreme trans-Neptunian objects. Let's just call them ETNOs for short. ETNOs are minor planets with an average distance of at least 150 astronomical units from the Sun. They have eccentric orbits, which can't be explained by the gravity of Neptune, Uranus, Saturn, or Jupiter. This led some scientists to conclude that Planet X must be out there. Ooh. As the years went by and more TNOs were discovered, scientists began to notice that those newly found objects didn't follow the previously established patterns. Many TNOs and ETNOs discovered in the last 5 to 6 years didn't match the same orbital parameters. Of the 6,000 objects found orbiting beyond 30 AU from the Sun, many show no signs of being influenced by a hidden planet. Well, despite that, scientists still hesitate to admit that Planet X is just wishful thinking. Not only is discovering something new exciting, but a planet like that could also protect us by pulling in asteroids from deep space. It could help explain why our solar system looks so different from many others, where super-Earths and mini-Neptunes are common. It might even solve how the solar system was formed, how objects got scattered, and what's still hiding in the dark. Discovering Planet 9 wouldn't just be cool, it could reshape everything we know about the solar system. However, with the discovery of 2017 OF201, actually that's still a mouthful, let's call it Ofie from now on. With the discovery of Ofie, the whole Planet 9 theory seems to be on its last legs. So, what makes Ofie so special, and how does it affect the idea behind Planet 9? The newly discovered member of our solar system is estimated to be about 430 miles in diameter. This places it in the dwarf planet category, certainly larger than many other trans-Neptunian objects, but still about 1/3 the size of Pluto. What stands out most is its elongated orbit around the Sun. It takes at least 25,000 years to complete one revolution. Its orbit brings it as close as about 45 astronomical units from the Sun, which is similar to Pluto's distance, and extends out as far as 1600 AU at its most distant point. This means it travels far beyond the Kuiper belt and approaches the inner boundary of the Oort Cloud. This orbit is not just extremely long, it's also highly eccentric, stretched out like a long oval. This puts it in a rare group of objects that travel to the most distant parts of our solar system. While there are objects with longer orbital periods, like comets that originate from the Oort Cloud, they're much smaller than this newly discovered dwarf planet. But despite its relatively large size for such a distant object, Ofie is nearly undetectable. It spends most of its time hidden from Earth's view, far from the inner solar system and too faint for current telescopes to spot. In fact, astronomers estimate it's only visible for about 1% of its 25,000-year orbit. In fact, this new dwarf planet came closest to the Sun in 1930, the same year Pluto was discovered, yet it slipped away unnoticed. Nobody spotted it back then, and it only got discovered in May 2025 completely by accident. By digging through archived data from publicly available telescopes, researchers pieced together its location from 19 separate images taken over 7 years. That's impressive detective work. So, what does all of this mean for Planet X? The archive photos have revealed that this object's orbit does not match any of the orbital clustering previously used to support the Planet 9 hypothesis. It doesn't belong to the same group as other ETNOs, and, more importantly, if a hidden planet is really tugging on celestial bodies, Ofie should have been flung out of the solar system millions of years ago. If Planet 9 was where we speculated and had the predicted mass, then Ofie's current orbit wouldn't last. It would likely be altered or even destroyed within about 100 million years. However, its orbit appears stable and undisturbed, suggesting it has been like this for far longer. But wait, you exclaim. If the mysterious orbit of Ofie is not caused by an invisible giant planet, what else could it be? Well, space is full of surprises, and gravity isn't exclusive to planets. One idea is that the orbit has been stretched over time by galactic tides. Just like the Moon pulls on Earth's oceans, the Milky Way galaxy itself pulls ever so gently on everything in the solar system. It's a slow, steady force. But if you're far out enough, like Ofie is, even that gentle tug can twist your orbit over millions of years. Now, another possible explanation could be that a passing star may have come to our solar system a long time ago, especially during its formation. Back when the Sun was young and surrounded by newborn stars, one could have passed close enough to give some outer objects a gravitational nudge. That kind of flyby could have easily yanked an icy object into a stretched-out, tilted orbit. The third idea is that such unusual orbits are leftovers from the early solar system, when planets and debris were being flung all over the place. Some may have ended up in stable but extreme orbits, like Ofie, the dwarf planet. If something really is pulling on these distant objects from outside our solar system, something like the galaxy itself, then we lack models to explain it. It's remarkable that we've managed to spot Ofie in the first place. These objects only appear when close to the Sun, so we've likely seen just a fraction of what's out there. There could be hundreds or even thousands of similar rocks, all with strange orbits and mysterious origins. Which means the real mystery might not be a hidden planet, but the hidden world of space rocks quietly orbiting in the dark, waiting to be found.
The James Webb Space Telescope, an astounding piece of equipment built to outperform the Hubble Space Telescope, has made a terrifying and amazing discovery that might completely change our perception of the universe. It has successfully detected a faint glow coming from a staggering 7 trillion miles away. Can this glow be shining city lights coming from some mysterious extraterrestrial world galaxies away from us? Well, let's start from the beginning. A few years ago, NASA's Infrared Spitzer Space Telescope helped us spot a family of 7 rocky exoplanets orbiting the same star. This star is known as TRAPPIST-1, and recently, our new infrared powerhouse, the James Webb Telescope, has measured the temperature of one of those distant worlds. It was a planet called TRAPPIST-1b. Unfortunately, it turned out that this Earth-like planet was totally uninhabitable. Astronomers took James Webb's mid-infrared camera, called MIRI, and looked at the planet's thermal emissions. We can picture the whole process as scientists using heat-sensing Terminator vision. The results were quite disappointing. TRAPPIST-1b turned out to be scorching. Its average temperature was around 450 degrees F. That's as hot as in an oven. Plus, the planet most likely doesn't have any atmosphere. At the same time, this discovery was another record-breaking first for the telescope, which had already produced some newsworthy results by that time. It was the first time researchers detected any form of light emitted by a small and relatively cool exoplanet similar to the rocky planets in our own solar system. No previous telescope had enough sensitivity to measure such dim, mid-infrared light. When 7 TRAPPIST-1 exoplanets were first discovered, the astronomical community was ecstatic. That's because all those faraway worlds were about the size of our home planet and located in their star's habitable zone. It's the region that is just the right distance away from a star for liquid water to exist on a planet's surface. Thus, the planetary system became the best place to look for rocky planets with an atmosphere. But don't get too excited yet. These planets aren't likely to become new worlds for humans to explore, mostly because the TRAPPIST-1 planets are totally out of our reach at the moment. They're just too far away, at a whopping 235 trillion miles away. Their star is also much smaller and redder than our Sun. It's classified as an M-dwarf star. In our home Milky Way galaxy, there are twice as many of such stars as there are stars like the Sun, and they're also twice as likely to have rocky planets orbiting them. It's probably not surprising that astronomers are very interested in such stars. They're the main targets for seeking potentially habitable planets, and it's also way easier and more convenient to observe rocky planets around such smaller stars. But there's a catch. M-dwarfs are more active than our Sun. They frequently flare and spew high-energy rays which are likely to be extremely damaging to planets' atmospheres and any forms of extraterrestrial life. When researchers examined TRAPPIST-1b before, their observations weren't sensitive enough to determine whether this world had an atmosphere, or if it was just a barren rock. But now, we know. The planet is tidally locked to its star, which means that one of its sides always faces the star, while the other is stuck in perpetual darkness. The latest simulations suggest that if this planet had an atmosphere, its temperatures would be much lower since the air would redistribute the heat around both sides of the planet. Unfortunately, the James Webb Telescope recorded much hotter temperatures than needed for such a favorable scenario. It indicates the absence of an atmosphere and knocks the planet off our list of possibly habitable worlds. But the main excitement here isn't actually the features of TRAPPIST-1b. The main takeaway is that James Webb is capable of making such kinds of measurements. It'll help us explore the atmospheres and temperatures of many other distant worlds.
All right, dear viewer, let's lay it out on the table. The case is cold, just like the rock we're looking for. It's that hypothetical planet again, a real slippery character, warping orbits from the shadows. I've been following its gravitational rap sheet for years. It has left a trail of math miscalculations and confused astronomers. But it can't hide forever. This solar system ain't that big. If it's there, we will find Planet Y. Yep, another day, another quest to solve the solar system's riddles. New research points to another hidden world. I have to say, we shouldn't dismiss these theories until they're disproven. Scientists these days are overloaded with a vast amount of data. Thankfully, they have supercomputers going through mountains of equations bound to give a headache to someone like me. But it's how these theories come to exist. At one point, even Neptune seemed like a far-fetched theory. When Uranus was discovered in 1781 by William Herschel, for decades, it looked like the solar system's final stop. But Uranus didn't quite follow the rules. Something was off. Either the laws were wrong or there was an invisible hand out there. Two math nerds, Adams in England and Leverrier in France, picked up the abacus, and there it was. Neptune appeared exactly where predicted. That's a cool point for math. That triumph inspired the next hunt. In the early 1900s, Percival Lowell became hooked on the Planet X theory. He was sure Uranus and Neptune were still wobbling funny, so he pictured a giant mystery world yanking their strings. His team hunted for years. And in 1930, Clyde Tombaugh found Pluto. Pluto is Planet X? Nope, not so fast. Pluto was too small, it didn't fit. The hype faded, and decades later, Voyager 2 showed that weird orbits made sense all along. Planet X, at least Lowell's version, had never existed. Then came Planet 9. In 2016, researchers noticed that distant Kuiper belt objects weren't scattered randomly. Their orbits clustered strangely, as if something was tugging them into line. They proposed a super-Earth, 5 to 10 times Earth's mass, orbiting hundreds of AU away. Simulations made it look convincing, but no one has seen it yet. A later discovery, a dwarf planet called 2017 OF201, made things even weirder. Some say it weakens the case for Planet 9. Others say it's more evidence. For now, Planet 9 is still a maybe. However, latest research points to another possible candidate, for now called Planet Y. Unlike the others, it's thought to be smaller, closer in size to Earth or Mercury, and hiding just past the Kuiper belt. Here's the big clue. Way past Neptune, some icy objects are all tilted, like a bunch of marbles moving to the same side while on a flat surface. That shouldn't happen. Gravity should have straightened them out ages ago. The simplest explanation? A hidden planet, quietly warping the outer solar system like a mischievous babysitter. Astronomers check those Kuiper belt orbits against the solar system's invariable plane, basically the balance point of all the planets combined. If things were normal, the orbits should line up, but they don't. They're all slanted the same way, like a bunch of pencils dropped on the floor, and somehow every single one points toward the same corner. According to researchers, the odds of that happening by chance are only 2 to 4%. That's similar to flipping a coin 5 times in a row and it landing on the same side each time. Astrophysicists ran their fancy calculations and came up with the simplest explanation. You guessed it, another object with strong gravity. The math shows that a world somewhere between the size of Mercury and Earth, orbiting 100 to 200 AU from the Sun, could maintain that tilt. Not too big, not too small, not too far, just the right size and distance to warp the Kuiper belt without throwing everything else into chaos. And here's where it gets fun. In theory, Planet Y could coexist with Planet 9. Planet 9 is supposed to pull icy orbits into clusters, kind of like a sheepdog rounding up sheep. Planet Y doesn't cluster anything. It tilts the whole playing field instead, which means if both turn out to be real, we might have 2 hidden planets shaping the edges of our solar system in different ways. So why haven't we seen this mysterious neighbor yet? Simple, it's faint. At 100 to 200 AU, sunlight is thousands of times weaker than here on Earth. A planet that far away could only reflect a tiny trickle of light. To our telescopes, it would look like a barely visible speck drifting across a crowded star field. Kind of like trying to spot a sleeping gray cat in a dark cellar with only faint moonlight coming through the window. It doesn't help that Planet Y would move at a snail's pace across the sky. Snap a photo one year and another a few months later, and it might not even look like it moved. Older sky surveys weren't designed to catch something that faint and slow. They're great for spotting fast-moving asteroids near Earth, but hopeless for a dim tortoise crawling at the edge of the solar system. But the hunt isn't over. Astronomers are putting their hopes on the Vera Rubin Observatory. This massive new telescope will take pictures of the night sky in unprecedented detail. If Planet Y is out there, Rubin could be the one to find it. And if it isn't, well, Rubin will give us the best proof yet that it doesn't exist. Who knows, maybe it spots something entirely different. But what if Planet Y is real? Where did it come from? Perhaps it's a leftover chunk from the solar system's wild early years. Billions of years ago, when Jupiter, Saturn, Uranus, and Neptune were still migrating, massive chunks of rock and ice were flung around like cosmic bumper cars. Some merged to become the planets we know today. Others were kicked out entirely, ejected into interstellar space. Planet Y might be one of the lucky survivors, massive enough to hang on in a stable orbit at the fringes. Another possibility is way cooler. Maybe it's a rogue planet. Planet Y might just be the cosmic equivalent of an adopted kid or a wandering stray that found a home. So what would it mean if Planet Y was real? First, it would mean a lot of textbooks getting another edition. New picture books as well. It would also challenge how we think planets form. A Mercury to Earth mass that far doesn't fit the standard model of planets forming near the Sun and staying put. Either the early solar system was wild enough to fling it outward and still keep it bound, or it didn't start here at all and was captured later, stolen from another star. There's another angle: comets. A planet out there could tug on icy bodies at the edge of the solar system, nudging some inward. Over time, that might even have helped deliver water and building blocks for life to Earth, but that's just speculation at this point. However, the biggest question of all would be, what else is out there? If a planet the size of Earth can still slip under our radar, then smaller worlds, icy dwarfs, and other mysteries could be waiting farther out. The Oort Cloud might be home to things we haven't even dreamed of yet. Finding Planet Y wouldn't just add a planet, it would open a new chapter in exploring the solar system. So, here we are at the edge of the map, where the streetlights of our solar system flicker out. It's just another theory on top of a dusty desk. Another clue to chase down a dark universe. Some leads have gone cold and turned out to be ghosts. Others, still out there, waiting to be found. Planet Y? The case is still wide open, but one thing's for sure in our solar system: as long as the orbits keep wobbling and the cosmic rug stays wrinkled, astronomers, they'll keep looking. They'll never stop searching for the last planet hiding in the endless dark. Maybe it's just a matter of time. We will see.
It's dark and incredibly cold. There's no oxygen. There's no water. There's no life. But the James Webb Space Telescope doesn't seem bothered by all this. Its main goal is to find the very first galaxies that formed billions of years ago in the early universe and observe the stars making up distant planetary systems. Its mission is to... But wait, what is that? The James Webb Space Telescope has discovered something absolutely amazing: a star-planet hybrid with very strange clouds. This bizarre world called VHS 1256b is actually a brown dwarf. Those are bigger than planets, but too small to classify as stars. They emit some light of their own and are quite hot, but their mass is simply not enough to fuse hydrogen into helium, like full-fledged stars do. Space bodies of this kind aren't actually brown. They occur in a wide variety of colors, but those are mostly invisible to the human eye. What we can see is the light they emit, and to us it appears to be dark orange or magenta. The brown dwarf we're talking about is almost 20 times the size of Jupiter. It orbits 2 red dwarf stars. And to complete one orbit, the brown dwarf needs 17,000 years. In fact, astronomers found out about this unusual exoplanet in 2016. But at that time, they didn't classify it as a brown dwarf, and thus couldn't explain its puzzling reddish glow. Now, thanks to the James Webb Telescope, they know the space object's origin. Anyway, back to those clouds. As you know, clouds on Earth are made of water vapor, but those on the brown dwarf are different. They seem to be made of sand. It looks like good old sand from Earth, but it's actually not. The clouds are made of tiny particles of silicate. Scientists have been putting forward theories about the existence of such sand clouds on exoplanets for quite some time. But the discovery the James Webb Space Telescope made is the first real proof. The silicate particles on the sandy dwarf are most likely quartz or some other mineral. In size, they're less than a micron, and 1 micron is 1/25th of a thousandth of an inch. In other words, they look like particles in smog. The exoplanet seems to have an atmosphere which contains some water, methane, and other substances and minerals. Interestingly, this atmosphere isn't still. It's constantly undergoing extreme changes. Another cool thing about it, scientists have detected carbon dioxide. And this is only the second confirmed discovery of this gas on a planet outside the solar system. By the way, the James Webb Space Telescope, with the help of which astronomers discovered our sandy brown dwarf, is an absolutely stunning piece of equipment. Around 100 times more powerful than Hubble. Even though the telescope itself is 3 stories high and its size equals that of a tennis court, its mirrors are the lightest large telescope mirrors of all time. When all the 18 mirrors of the telescope were completed during the manufacturing process, their mass was reduced by 92% in comparison to the initial discs. Each mirror weighed a mere 44 pounds. The telescope's mirrors seem to be gold, but in reality, they're made of beryllium, steel gray, lightweight, and brittle metal. There is indeed a gold coating on each mirror, but they can't be produced entirely out of gold since this material tends to expand and contract even with small temperature changes. That's why the total amount of gold in the James Webb Space Telescope is less than 2 ounces. James Webb's telescope side is cooling itself down, and its temperature doesn't rise higher than -370 degrees Fahrenheit. That's cool enough to make liquid nitrogen. A truly enormous 5-layered sun shield stretches around the telescope and reflects away as much sunlight as possible, letting the telescope stay cool. The telescope was launched near the equator because Earth spins a bit faster there, and this gave the rocket some extra push. The telescope orbits the Sun more than 1 million miles away from Earth, and when it runs out of fuel, it'll keep orbiting the Sun indefinitely. On the other hand, even though the telescope wasn't actually designed to be serviced or upgraded, it might potentially be refueled with the help of robots. This would extend its life. Anyway, if you think that our newly founded brown dwarf is the only bizarre exoplanet out there, let me show you some other breathtaking worlds. There is an exoplanet that is really something else. Just look at its awesome magenta color. You can find it in the Virgo constellation. The planet is called Gliese 504b. It orbits very far from its parent star, 9 times the distance between the Sun and Jupiter. The planet formed relatively recently and is still glowing with heat. That's why its surface looks pinkish. One of the oldest exoplanets we know about is about 12.7 billion years old. It's almost 3 times as old as Earth. This also means that the so-called Genesis planet formed only about 1 billion years after the Big Bang. The planet is so old that its 2 parent stars have had enough time to evolve into a white star and a pulsar, making almost 100 revolutions per second. I bet sunrises on this planet must look awesome. Just 20 light-years away from the Sun, which isn't such a great distance when we talk about space, a bizarre rogue planet is roaming the Milky Way galaxy. But even though this planet doesn't orbit any star, it still has an incredibly powerful magnetic field. It's 4 million times stronger than Earth's. The exoplanet also produces amazing auroras. That's why when it was discovered in 2016, astronomers were almost sure they had detected a brown dwarf. But later, scientists got some proof that this space object wasn't big enough to be a brown dwarf. The planet sure is a mammoth among its peers. It's 1.2 times as wide as the largest planet in the solar system, Jupiter, and more than 12 times as heavy. Astronomers think the exceptionally strong magnetic field helps the planet produce auroras. But the most curious thing is that they're generated in a different way than auroras on Earth. It might be because the exoplanet's moon helps the planet create mesmerizing light shows. The next exoplanet isn't like any other. It's often called Super Saturn or Saturn on steroids. That's because J1407b has a colossal system of rings. They're 640 times as large as those our Saturn has. This bizarre world is the only planet we know about that has rings similar to Saturn's. If you moved this giant to our solar system and used it to replace Saturn, its rings would look many times larger than a full moon. An exoplanet called WASP-12b munches on the light coming from its star. It's one of the darkest worlds people know about. All because its day side consumes light rather than reflects it back into space. The egg-shaped planet is giant, twice the size of Jupiter, and it traps more than 94% of the light that reaches its atmosphere. It might be the main reason for the temperatures on the surface of the planet that can rise up to 4,600 degrees Fahrenheit. The night side of the planet isn't as hot as its day side, a mere 2,200 degrees Fahrenheit. The difference in temperature makes water vapor and clouds gather above the surface of the planet. And from time to time, swirls of material from the planet's superheated atmosphere spills onto its star. What of you? Discovered in 2017, KELT-9b is one of the hottest exoplanets we know of. The temperatures there can reach 7,800 degrees Fahrenheit. For comparison, the temperatures at the surface of the Sun reach 10,000 degrees Fahrenheit. The planet is probably so insanely hot because it orbits extremely close to its star, KELT-9, which is way hotter and bigger than our Sun. Experts believe that the giant star might one day evaporate the entire planet.
For thousands of years, people knew only about the planets Mercury, Venus, Mars, Jupiter, and Saturn, which they could see using simple telescopes, or even by the naked eye if conditions were good. But in the late 18th century, a famous astronomer named Sir William Herschel discovered a new planet that was icy blue in color. At first, people thought it was a star, but later they realized it was a planet. Today, we know it as Uranus, a planet that's more than 19 times farther away from the Sun than Earth. It's so far away that it takes Uranus 84 years to complete one trip around the Sun. This astronomer also discovered many other interesting things in space, like double stars and nebulae. In the mid-1800s, scientists noticed something pulled Uranus and strangely tugged its orbit. They thought there must be another planet out there, and they used math to predict where it would be. Finally, in 1846, they found Neptune using a telescope. It was too faint to see with the naked eye because it was too far away from the Sun. It was all so exciting. Who knows how many other planets could be there, lurking in the darkness of our solar system? Back in the mid-1800s, astronomers noticed something unusual was happening in the sky. A small rocky planet named Mercury was behaving strangely. It didn't follow the predictable orbit that was expected of it. One of the astronomers was a brilliant French scientist named Urbain Le Verrier. He came up with a theory that there could be another planet in our solar system no one had yet discovered. It would be located somewhere between Mercury and the Sun. This hypothetical planet, which he named Vulcan after the Roman god of fire, would have an incredibly hot surface, and it could be a potential explanation for Mercury's strange behavior. He never surely claimed Vulcan was really the one thing disturbing the orbit of Mercury. But, excited by the possibility of discovering a new planet, astronomers all over the world took the idea of Vulcan. For a planet that didn't exist, people committed to developing ideas and getting information about it. Some scientists didn't think it was likely that they had missed another planet as big as Mercury. It would have been hard not to see it by then. But there was a tiny chance of a smaller planet existing inside Mercury's orbit that was too close to the Sun, so no one could see it. One theory said it was about 13 million miles away from the Sun. Mercury is the planet with the most eccentric orbit in our solar system, but the closest point it gets to the Sun is about 28.5 million miles. This means Vulcan would be under half of that distance. The theory moved on, saying that if Vulcan existed, it would orbit the Sun every 19 days and 18 hours, and its path would be tilted about 12 degrees relative to the path of other planets in our solar system. Vulcan's position at its furthest point from the Sun would still be too close to the Sun to be seen with the naked eye, even during twilight. The only chance of seeing Vulcan would be during a solar eclipse, or when it passed in front of the Sun, which, as the theory said, would be 2 to 4 times a year. They had a theory that this mysterious planet was so close to the Sun that it could only be seen during a total solar eclipse when the moon blocked out the Sun's blinding glare. So, every time there was an eclipse, scientists would peer at the Sun, hoping to catch a glimpse of Vulcan. They were trying really hard, but no matter what, they couldn't find this mysterious planet. Some astronomers claimed to have spotted it during eclipses, but no one could ever confirm or find evidence for that. The theory of Vulcan was left waiting for some better times. Einstein had a different idea. You know about his theory of general relativity, right? That's where he claimed gravity wasn't some sort of natural force, but a result of space-time curved because of the presence of giant space objects, like planets and stars. Planets circle around the Sun in their usual orbit because space-time is curved. That means the planets are kind of falling towards the central star of our solar system. And Einstein tried to explain Mercury's unusual orbit using his own theory of relativity. Unlike the other planets in our solar system, Mercury's orbit wasn't that circular. Instead, it seemed to wobble slightly, as if there was an invisible force pulling it away. Einstein said this could be happening because the massive gravity of our Sun was actually curving the fabric of space-time around it. He claimed it's possible this changed Mercury's orbit a little bit. It took the scientific community a while to test this theory, but it eventually seemed like the most plausible explanation. Even though Einstein's theory gave us a more elegant explanation for Mercury's strange orbit, some scientists were still holding out hope for Vulcan. It was especially hard to let go of the idea of Vulcan because Mercury is also the planet that's really hard to see from where we're standing. But later, more and more scientists started accepting Einstein's theory above their imagination. And they would observe a total solar eclipse specifically to test Einstein's theory of relativity, not because of Vulcan. And Vulcan is not the only hypothetical planet everyone was talking about. In the newer age, some believe there could be a mysterious planet lurking in the outer part of our solar system. But this one is more likely to exist. No one has seen it directly yet, but computer simulations show this so-called Planet 9, or Planet X, is probably somewhere there beyond Neptune. Neptune and Planet X could be similar in size. Planet X could be 10 times more massive than Earth and circles around our Sun in an elongated shape, which is on average 20 times farther from the Sun than Neptune. A year there may last between 10,000 to 20,000 Earth years. By comparison, a year on Neptune lasts 165 Earth years. Something this big moving out there beyond Neptune could explain the unusual orbits of smaller objects in the Kuiper belt. The Kuiper belt is the area of our solar system beyond Neptune and where it orbits. And there are most likely many asteroids, comets, and some other smaller bodies there, mostly made of ice. There was another hypothetical planet called Nibiru. Remember those rumors that the world could end back in 2012? One of the popular scenarios was Nibiru, which some claimed would hit our home planet at the end of the year. Of course, nothing happened. We're still here, all set and good, but the idea of Nibiru seemed interesting. Stories started in the 1970s when a man named Zecharia Sitchin mentioned Nibiru in his book, The 12th Planet, claiming it orbits the Sun every 3,600 years. But there's no chance a planet with such an eccentric orbit wouldn't disrupt other planets in our solar system with its gravity. And if it was really coming that close to Earth in 2012, we were supposed to be able to see it with the naked eye. Some simple calculations showed Nibiru would have been nearly as bright as Mars at its dimmest, and brighter than the faintest stars you see from a city. Oh well, maybe we'll have more luck in the next 3,500 and something years. In 2011, a comet named Elenin appeared that many people thought could be Nibiru. But when you're looking at comets and planets through a telescope, you see they appear differently. A comet has a coma, which is a gas atmosphere, together with a tail, something a planet doesn't have. Plus, this comet didn't slam into the Earth. It came too close to our Sun and fell apart. The leftover pieces will continue moving on their way to the outer solar system for the next 12,000 years.
It's been more than a year since the James Webb Telescope, which had taken over 20 years to complete, was launched. And for such a relatively short time, the ultra-modern and most powerful in history piece of equipment has already made plenty of discoveries. By observing the universe at infrared wavelength, James Webb lets us see things no other telescope has ever shown before. The primary goal of this incredible piece of equipment is to study the formation of galaxies and stars that appeared in the early universe. For example, look at the closest to us stellar nursery, a region of space where new stars get born. NASA has shared an image from James Webb that shows a small star-forming region. If you look at the picture attentively, you'll see jets bursting from infant stars. Around them, different colored clouds of cosmic dust are colliding with one another. The view is mesmerizing. The red dust consists of molecular hydrogen. You can also notice that some stars have something like shadows. Those hint at the creation of what will later become planets. At first sight, the image may seem chaotic, but astronomers claim that it's a relatively small and quiet stellar nursery in comparison to some others. Many young stars there are similar in size to our Sun, or a bit smaller. The photo itself was taken with the help of Webb's near-infrared camera, NIRCam. It's the observatory's primary camera that snaps images of the cosmos in 2 different infrared ranges. Another amazing discovery the Webb telescope has made is smoke molecules in a distant galaxy. It's the first time such molecules have been discovered so far away from our planet. The galaxy in question lies 12.3 billion light-years away from Earth. It most likely formed about 1.5 billion years after the Big Bang. Despite such a huge distance between the galaxy and our planet, scientists have managed to detect chemical compounds found in soot or smoke, and it's quite a big deal since it has pushed the record for detecting similar complex molecules back by around 1 billion years. This study has also confirmed the sheer power of the coolest piece of space equipment of all time. It managed to make this discovery despite the fact that the spectrometer needed for the measurements didn't perform to the fullest after having experienced a sudden and surprising degradation. The James Webb Telescope has also helped to boost our understanding of exoplanets. Those are planets orbiting stars other than our own Sun. At the beginning of 2023, the observatory spotted its first exoplanet, LHS 475b. It's located 41 light-years away from Earth and is approximately the same size as our planet. According to NASA, nowadays, James Webb is the only operating telescope capable of categorizing the atmosphere of Earth-sized exoplanets. The research team behind the discovery believes such results underline the precision of the telescope. They hope that it will help us locate many more rocky exoplanets that we might be able to colonize in the future. Even though, at first sight, it may seem that the universe is pretty empty, it's actually a very busy place.
And Webb has all the necessary instruments to see all kinds of cosmic events happening out there. Just look at this image of WR 124. It's a star on the cusp of its explosive demise. In the image, the star is about to go supernova. It happens when a star runs out of its fuel and explodes at the end of its life cycle, releasing a giant cloud of space dust and hot gas into space. The star captured by the Webb telescope was at the Wolf-Rayet stage of its life. That's a period when a star is shedding its outer layers before going supernova. The next amazing thing discovered by James Webb is a star-planet hybrid with very strange clouds. This bizarre world, VHS 1256b, is actually a brown dwarf. Those are bigger than planets but too small to classify as stars. They emit some light of their own and are quite hot, but their mass is simply not enough to fuse hydrogen into helium like full-fledged stars do. Space bodies of this kind aren't actually brown. They occur in a wide variety of colors, but those are mostly invisible to the human eye. What we can see is the light they emit, and to us, it appears to be dark orange or magenta. The brown dwarf discovered by the Webb telescope is almost 20 times the size of Jupiter. It orbits 2 red dwarf stars, and to complete one orbit, it needs over 10,000 years. Astronomers first found out about this unusual exoplanet in 2016. But at that time, they didn't classify it as a brown dwarf, and, thus, couldn't explain its puzzling reddish glow. Now, thanks to the James Webb telescope, they know the space object's origin. Anyway, back to those clouds. As you know, clouds on Earth are made of water vapor. But those on the brown dwarf are different. They seem to be made of sand. It looks like good old sand from Earth, but it's actually not. The clouds are made of tiny particles of silicate. Another recent discovery involves several large galaxies that scientists believe were born not long after the Big Bang. They aren't supposed to be there, and no one expected to find them. But the James Webb Space Telescope has spotted them. These galaxies, as massive as our home Milky Way, are full of mature red stars. Astronomers have analyzed the light coming from them and estimated their age 500 to 700 million years after the Big Bang. It means that they came into being when our universe was very young, almost a baby. But the most bizarre thing about these galaxies is their tremendous size and the age of the stars dwelling there. The data received by the telescope don't coincide with the existing ideas about what the universe looked like and how it evolved in its early years. It also doesn't match the earlier observations made by Hubble. And here, James Webb has captured a distant region of space in unprecedented detail. This section of space is known as Pandora's cluster. In the image, you can see 3 massive clusters of galaxies coming together and forming a megacluster. The combined mass of these clusters acts as a powerful gravitational lens. And thanks to this natural magnification effect, scientists can see other galaxies in the region. Astronomers claim that the most recent image of Pandora's cluster is stronger and deeper than they have ever seen. James Webb has also managed to spot thousands of young stars never seen before in the Tarantula Nebula. This space formation got its nickname because of the appearance of dusty filaments spotted in previous images. It's the biggest star-forming region in the local group, which includes the galaxies nearest to the Milky Way. The Webb telescope's images have helped to shed light on the composition of the Tarantula Nebula. The telescope has also detected protostars, infant stars in the process of gaining mass. Astronomers expect that these protostars will eventually form and shape the nebula further. Among other discoveries made by the James Webb Telescope, you can see the birth of 50 distant stars. Some of them power protoplanetary disks, which might later form solar systems light years away from our own. Here's one more image from James Webb. You can see a supermassive black hole that has a mass of 9 billion suns. It's so ginormous and ancient that scientists are struggling to explain its existence. Astronomers have also discovered a distant ring of dust, rock, and gas that contains a chemical called methylcation. It's known as a molecular building block of life, and it makes most of the organic material on our planet. James Webb helped researchers see powerful sandstorms on a planet 235 trillion miles away. Astronomers were happy to discover this treasure chest of countless tiny sand particles. Now look at this. Do you recognize this image? Those are the so-called pillars of creation. But this new view shows us just how star-speckled that dusty region actually is. You can compare the new photo with the one taken by Hubble in 2014. This is astonishing proof of scientific progress.
Now, if Earth were the size of a nickel, Neptune would be about as big as a baseball. That's impressive, but it's nothing compared to the giant ninth planet that might be hiding out there. Now, our Planet 9's discovery saga might have finally come to an end. Turns out, the problem wasn't where we were looking, but how. And researchers might have just made the biggest solar system discovery in decades. You see, the idea of finding a planet beyond Neptune has been around for years now. I know, back in school, you probably learned that the ninth planet was Pluto. But forget about Pluto. It's been demoted to a less fancy category since 2006. What I'm talking about is the Planet 9, a hypothetical giant planet that could be our cosmic neighbor. We've never actually seen it, but scientists are pretty sure it's out there somewhere, hiding in the outer solar system. To explain why they think that, we need a sheet of paper. Hey, here's one. We place a coin on it, and suddenly, it starts to move. Unless we're talking about some kind of superpower, there's no way this coin is moving on its own, right? So, you figure someone must be on the other side, holding a magnet and moving it around. You can't see the magnet, but it explains why the coin is moving. That's kind of what's happening with Planet 9. We can't see it, we can't prove it, yet, but its existence could explain the strange movements we see out there in space. For example, the planets in our solar system orbit on a flat plane that's tilted about 6 degrees relative to the Sun. But why 6 degrees? Well, no one really knows for sure. Some scientists think those orbits might be slightly tilted because of the pull of a ninth planet. Its existence could also explain the unusual paths of smaller objects in the distant Kuiper belt, a region full of icy debris that stretches far beyond Neptune's orbit. Back in 2016, researchers from Caltech published a study about Planet 9. They suggested it could have a mass about 10 times that of Earth and follow a highly elongated path. It's a scientific way of saying it takes forever to make one trip around the Sun. Because of that, it would be located in the outer solar system, far, far away. It would orbit the Sun about 20 to 30 times farther out than our most distant planet, Neptune. According to scientists, Planet 9 would take up to 20,000 Earth years to complete just one full orbit around the Sun. Since it's crazy far out there, it's almost impossible to see it. So, as cool as this hypothesis sounds, we've never found solid evidence that Planet 9 actually exists. But we might be pretty close. In May 2025, a team at National Tsinghua University might have made one of the most exciting solar system discoveries ever. Alright, so there's a hypothesis that Planet 9 hasn't been discovered yet because we haven't been using the right method. This new study raises an interesting question. What if Planet 9 actually looks brighter in infrared light than it does in visible light? Let me explain. Scientists have been trying to spot Planet 9 by its reflected light. But here's the problem. To spot it in visible wavelengths, sunlight would have to travel all the way out to Planet 9, bounce off its surface, and then travel all the way back to Earth. If a Neptune-sized planet were about 10 times farther away than Neptune, it would look about 10,000 times fainter. But a planet's own thermal radiation, its heat, only has to make a one-way trip. So in infrared light, Planet 9 would only be about 100 times fainter. That's why it makes more sense to look for it using space-based infrared telescopes. And that's the idea behind this new study. The team started digging through archives, searching for old infrared sky survey data, and they pulled it from two main sources. First, IRIS, a satellite launched in the 80s that scanned the sky for almost a year. Then, the Japanese satellite Akari, another infrared observatory that operated between 2006 and 2011. So basically, they compared objects that showed up in IRIS database and noticed which ones had moved by the time Akari took its observations. And by doing that, the researchers found something incredible, an object that might just be our long-lost ninth planet. Because if something moves, it could be a planet orbiting the Sun, right? And yeah, they did find some celestial objects showing tiny movements. But before jumping to conclusions, they had to rule out the parallax effect. And that's something really important when we're talking about solar system discoveries. To explain it, I need you to do something. Hold one finger in front of your face. Close one eye, and now switch. Your finger seems to move a tiny bit, right? That's because you're looking at it from a slightly different angle, from one eyeball to the other. The same thing happens when we look out into space from Earth. Since our planet orbits the Sun, our view of very distant objects shifts just a little. That effect is called parallax. My point is, because of this effect, Planet 9 would appear to move across the sky as Earth goes around the Sun. On any given day, it might seem to be in one spot, but 6 months later, when Earth is on the opposite side of the Sun, it would look like it shifted. 6 months after that, it would seem to move back again. Scientists had to account for parallax. Actually, they had to remove its effects. So the team looked at images of the sky taken on the same date every year. Because on that same date, Earth is always in the same spot in its orbit. That means if Planet 9 is real, it would show up in the same place in those images every year. No fake wiggle from parallax, just its real position. This careful search led them to a single object, a tiny dot in the infrared data. This strange little spot had moved slightly along its orbit around the Sun over the 23 years between Iris and Akari. Wait, could that be it? Did astronomers just confirm a hidden planet? Well, maybe. But don't get too excited. The data we have on its motion over that time is not enough to figure out its full orbit. So, for now, we still can't say for sure if this mysterious object is really Planet 9. It's definitely a strong candidate, though. Based on how bright the object appears, the team estimates it could be pretty massive, and that came as a big surprise. You see, previous NASA research ruled out any Jupiter-sized or Saturn-sized planets hiding out there, but a smaller world would have gone undetected. So the scientists were looking for something just a bit bigger than Earth. But it turns out this mysterious planet might be more massive than Neptune. Now that they've discovered Planet 9, supposedly at least, the plan is to keep tracking it and collecting new data. But don't think the road ahead will be easy. Because since the Akari satellite spotted it for the first time, that object didn't just sit still. It's been moving slowly through space ever since. So now scientists need to use regular telescopes on Earth to look for it again. And here's the tricky part. They're not exactly sure where it moved to, so they have to search a pretty big patch of the sky. And so far, no matching object has been found. Whether this really turns out to be the Planet 9 discovery or not, only time will tell. For now, its existence is still up for debate. But with powerful new technology on the way, like NASA's Nancy Grace Roman Space Telescope, astronomers are more determined than ever to uncover the truth. And if Planet 9 really is out there, hiding in the cold, dark edges of our solar system, it's running out of places to hide. A recent shocking discovery, shocking I tell you, shows that one galaxy can devour another smaller one, leaving behind just faint remains. Can anything like this happen to our home Milky Way galaxy? And if it does, what will happen to the inhabitants of the planet Earth? You know, us. Well, let's figure it out. This whole discovery is actually a curious story. Even before the Rubin Observatory, an astronomical observatory in Chile, even started its full science work, it accidentally helped astronomers spot something totally unexpected. In June, the team released its very first test images, and one of them showed a deep look at the Virgo cluster. That's a huge group of nearby galaxies scientists have been studying for years. But in the bottom right corner of that image, there was something thin and strange, and it wasn't me. It was a tiny razor-sharp streak of stars stretching away from a well-known galaxy called M61. No one had ever seen it before. Now, M61 looks a lot like our own Milky Way galaxy. It's a barred spiral galaxy with long, sweeping arms. But despite the similar shape, the center of M61 is far more dramatic. While Milky Way's supermassive black hole sits quietly, almost as if it's asleep, M61's black hole is wide awake and hungry. It feeds on surrounding matter and blasts out powerful flows of energy, which creates a kind of galactic storm that spreads through the galaxy. M61 has been studied for decades, but Rubin's camera is built to pick up things that are extremely faint. That's why this new star system suddenly appeared. It was as if someone turned on a flashlight in a dark room. Now, the stream is enormous. It's about 50 kiloparsecs long, which is roughly 163,000 light-years. That's more than the size of the entire Milky Way. Most stellar streams around our own galaxy are only a few tens of thousands of light-years long, so this one is huge by comparison. Scientists think that the long trail is made of a dwarf galaxy that got too close to M61. Once it crossed into the larger galaxy's territory, the dwarf galaxy became trapped in its gravitational grip. Little by little, powerful tidal forces began pulling it apart, stretching it into a long, faint trail of stars. Eventually, it was completely ripped apart by M61's gravity. When that happened, the larger galaxy seemed to have responded with a burst of new star-making about 10 million years ago. It almost felt like the collision kicked it awake. This process, large galaxies tearing smaller ones apart, is thought to be one of the main ways galaxies, like the Milky Way and M61, grow over billions of years. Each smaller galaxy that falls in becomes fuel for the larger one, adding stars and gas, and sometimes this process can even stir up activity around the central black hole. Will our Milky Way become that smaller galaxy one day? Well, we do have a much bigger neighbor, the Andromeda Galaxy. But at the moment, we can't predict whether it'll get hungry enough to attack the Milky Way. Whew, what a relief. Anyway, it might seem weird that the M61 stream had gone unnoticed for so long. It wasn't exactly faint or subtle, glowing with the light of about 100 million suns. Hard to miss. But it managed this trick by staying hidden behind a nearby galaxy. This makes it really difficult to detect even bright stellar streams. To find them, we need extremely sensitive instruments and careful techniques. At least now we know that giant galaxies may grow by eating smaller ones, leaving long trails of stars behind as evidence. The researchers admit that it's surprising that such a huge structure stayed hidden around a famous galaxy for so long. And it seems that the discovery of the M61 stream is just the beginning. The night sky might start filling with new uncovered structures, ghostly trails, forgotten galaxies, and the remains of ancient cosmic encounters. The Rubin Observatory is a brand new astronomy center built on a mountain in Chile. Its full name is the Vera C. Rubin Observatory. It was named after the astronomer who first found strong evidence that dark matter is real. Now, what makes Rubin special is that it's the first telescope of its kind. Its giant mirrors, super-sensitive camera, fast movement, and powerful computers all use cutting-edge technology. The main telescope, called the Simonyi Survey Telescope, has a 27-foot mirror, and it uses the LSST camera, which is the biggest digital camera ever made. But we'll talk about it a bit later. For 10 years, this telescope will take extremely detailed pictures of the southern sky. It will scan the entire sky every few nights, creating a huge, high-quality time-lapse video, the largest movie of the universe ever recorded. This movie will help scientists spot things that change over time, like asteroids, comets, stars that get brighter or dimmer, and exploding stars called supernovae. To create this giant time-lapse, the Rubin Observatory will have to use a lot of new technology. Some of its parts were invented from scratch, and others were improved versions of older designs. It'll help scientists discover all kinds of things. Many we already expect, and many we can't even imagine yet. Even so, Rubin Observatory was built with 4 main science goals in mind: learning more about dark matter and dark energy, creating a complete list of objects in our solar system, mapping the structure of the Milky Way, and studying objects that move or change brightness over time. Everything about the telescope, its huge size, fast scanning speed, and ultra-sensitive camera, was designed to make discoveries in these 4 areas as complete as possible. Rubin's telescope isn't the first telescope with a mirror about 27 feet wide, but it is the first to combine its primary mirror and tertiary mirror into one single surface. Putting both mirrors together is a special innovation that makes the entire telescope more compact. Because of this, it can move faster and get ready for its next observation much more quickly. The telescope's LSST camera is the biggest digital camera ever created. It's about the size of an SUV and weighs around 6,000 pounds. It holds a giant 3,200 megapixel CCD array. Just one single picture from Rubin is so large that you'd need about 400 Ultra HD TV screens to display it. It's also the fastest-moving large telescope on Earth. Rubin's telescope can swing into a new position in only 5 seconds and immediately start taking its next image. The speed comes from the telescope's compact design, thanks to its 2-in-1 mirror and its powerful drive motors. They can quickly move and stop the 220-ton telescope mount without shaking it. Even small vibrations can ruin an image, so this stability is a huge achievement. By the way, if the telescope were spinning at full speed, you wouldn't be able to outrun it. Also, Rubin Observatory has a rare combination. It can collect a lot of light and capture a very large area of the sky in a single picture. This means it can spot faint objects spread out over a wide region without needing many separate images. When you add the telescope's incredible speed, you get the perfect setup for creating Rubin's ultra-high-definition 10-year time-lapse of the universe. A fun fact, each Rubin image covers about 10 square degrees of sky. That's the same area as 45 full moons, or about the size of a golf ball held at arm's length. Another cool thing is that Rubin data will be immediately available to scientists in the US and Chile, and to members of Rubin's International In-Kind program. They'll be able to access everything through an online portal, which means that no giant downloads are needed. After 2 years, the entire world will be able to view Rubin data. Rubin will also process new images every night in near real time. If something in the sky moves or changes, the system will send out a public alert within 60 seconds. This will allow scientists to respond quickly and point their telescopes at the event. Each night, Rubin Observatory will create 20 terabytes of data and send out up to 10 million alerts about changes in the sky. By the end of the 10-year survey, Rubin will have produced a whopping 60 petabytes of raw images. It'll be the first time so much astronomical information is shared with so many people.
How about a mysterious object that used to orbit between Mars and Jupiter? At one point in the early days of the solar system, it was destroyed by some catastrophic event. This space body is called Phaeton, and this planet is totally hypothetical. But some people believe that the debris the planet left behind could have formed the asteroid belt. If you like this kind of content, please give it a non-hypothetical like and subscribe. Your support is very important to us. Thank you. Now, at the start of the 19th century, people hadn't discovered the asteroid belt yet. But in 1801, one astronomer spotted the largest asteroid in our solar system, Ceres. At that time, it was believed that a planet was orbiting between Mars and Jupiter, and Ceres seemed to be a suitable candidate. But the next year, another astronomer discovered one more space object with a similar orbit. It was an asteroid that was later named Pallas. These discoveries made scientists conclude that these two objects could have been fragments of the very planet that had once been dwelling between Mars and Jupiter. The following discovery of two more asteroids, Juno and Vesta, seemed to confirm this idea. Only in the 20th century did the hypothetical planet get its name, Phaeton. It was actually a name taken from Greek mythology, meaning shining one. The hero with this name was the son of the sun deity, Helios, who rode his solar chariot across the sky every day, giving humans the heat and light necessary for survival. One day, Helios allowed Phaeton to drive his chariot. But the sun didn't manage to control the horses. Everything went wrong, and Earth was about to burn down. That's why the main deity, Zeus, had to stop Phaeton with a thunderbolt. The idea of the asteroid belt being the sad result of the planet's destruction was called the disruption theory. And of course, there were several ideas explaining the planet's tragic fate. The most obvious one is that Phaeton was hit by a large space object. It could be another hypothetical body called Nemesis. Some people believe that it's our sun's companion star. According to this theory, the sun has a small companion star that has an extremely elliptical orbit. This orbit periodically brings it close to the Oort Cloud, a large sphere of icy objects surrounding the Sun. This, in turn, causes a lot of mess. It might be the reason why this hypothetical companion star was also nicknamed the Death Star. It might be a red or brown dwarf. But whatever it is at the furthest point of its orbit, it's believed to be about 1.5 light-years away. The search for this star has been in progress for decades, but no one has succeeded in locating this elusive and potentially non-existent space object. Anyway, back to Phaeton. Another theory claims that the planet could have suffered some internal cataclysm which tore it apart. But these days, the disruption theory has fallen out of favor. It was replaced by the accretion theory. According to it, the asteroid belt formed in the process of gradual buildup of particles initially floating in a gaseous environment. With time, they came together to create larger masses. Gravity pulled on these particles, encouraging them to stay together and form planetesimals, tiny planet-like bodies that later form real planets. Planetesimals kept colliding with one another, eventually developing into protoplanets. Such protoplanets grow until they form planetary bodies. As the mass of objects increases, the gravitational forces acting between particles become stronger too, continuing to build gas, dust, and ice within the nebular disk. It all has a snowball effect where the increase in mass results in more particles getting involved in the process. Eventually, there's no building material left, and large space objects float in the darkness of space. Now, many experts think that the asteroid belt is the remains of the protoplanetary disk which had once been orbiting the Sun before the planets formed. Unfortunately, it never had a chance to coalesce into a planet because Jupiter's gravitational effect prevented it from happening. In any case, even though Phaeton's was a good story, it's not popular anymore.
At the edge of our solar system, there's a cold and mysterious region known as the Oort Cloud. It's a hypothetical vast area of icy space objects surrounding the Sun. It's believed to lie far, far away from our star, from 2,000 to 5,000 astronomical units. For comparison, Pluto's orbit carries the planet between 30 and 50 astronomical units from the Sun. And there, in this freezing emptiness, a rogue planet may be hiding right at the moment. At least, that's what new research has recently suggested. Rogue planets are called this way because they don't orbit around any star. They wander the galaxy alone, totally untethered. Without stars, they don't have days or nights, only eternal darkness. Rogue planets are usually kicked out of their planetary systems, doomed to a solitary existence of circling the center of the galaxy on their own. Of the thousands of planets scientists have detected outside of our solar system, only a dozen or so are starless and cruising on their own. At the same time, there might be billions or even trillions of rogue planets wandering around our galaxy. If these estimations are true, it might mean that the Milky Way contains more free-floating planets than stars. Anyway, in 1907, one astronomer started a search for Planet X. It's a hypothetical giant planet moving around the Sun beyond the orbit of Neptune. The scientist was convinced that this planet existed because he had observed some irregularities in the orbits of Uranus and Neptune. His idea led to the discovery of Pluto in 1930. But the dwarf planet was too small to have any serious gravitational impact on the orbit of Neptune, let alone Uranus. These days, the Planet X theory is largely considered to be discredited, but it hasn't stopped astronomers from searching for planets in the far reaches of our solar system. And shockingly, a new study claims there might be one or even more out there, but much, much further away than predicted. An international team of scientists has recently simulated the unstable celestial mechanisms of the early solar system. They've discovered that there's a possibility that a few planet-sized bodies might have come to rest in the Oort Cloud. You see, about 4.5 billion years ago, when the solar system was just forming, it was a hectic and unsettled place. Gravity sent debris from the cooling protoplanetary dust cloud hurtling around like cosmic tennis balls. From time to time, large chunks of this debris, even planet-sized ones, were sent flying far enough to escape the sun's gravity altogether. Such pieces of debris turned into rogue planets. Researchers have seen such space wanderers in distant exoplanetary systems, but according to them, there's a 0.5% chance that one or more of those wayward planets formed in the solar system and ended up in the Oort Cloud after drifting away from the sun. At the same time, it's slightly more likely that a rogue, Neptune-like planet was snagged by the sun's gravity from another planetary system. And then, this planet came to rest somewhere in the Oort Cloud. The chances that this scenario is true reach 7%. If this turns out to be the case, then a space body similar to Planet X might indeed be hiding out there, on the outskirts of our solar system. The only problem is that it would still be too far away to have any impact on Neptune's orbit. In any case, most researchers are convinced that the Oort Cloud is made up of a collection of way smaller icy objects. But given the distance to the Oort Cloud and its enormous size, we may never really figure out what is lurking out there.
So, we might be getting closer to finding a massive icy planet beyond Neptune's orbit. Sorry Pluto, still not you. Recently, some universe mapping using data from a telescope in Hawaii eliminated about 78% of the possible locations for this mysterious Waldo from space. Some people call it Planet 9, while others prefer Planet X. Either way, it's been causing controversy since its existence was first proposed, and that is mainly because no study so far can answer the big question: does it really exist? If discovered, Planet 9 would rank as the 5th largest planet in our solar system, with a mass 10 times that of Earth. It's also theorized to be gaseous, like Uranus. The initial study on Planet 9, dating back to 2016, suggests that this colossal new planet orbits the Sun 29 times farther out than Neptune, which sits at about 2.8 billion miles. As a result, the Planet 9 would take between 10,000 and 20,000 years to complete a single orbit around the Sun. If confirmed, this yet-to-be-understood world would dominate a region larger than any other known planet in our cosmic neighborhood. These are all intriguing hypotheses, but without a single piece of evidence or observation to back them up. Before dismissing this as a wild guess, it is important to note that these researchers relied on complex mathematical modeling and computer simulations to speculate about the planet's characteristics, because that's what they do. The hypothetical presence of this planet would explain various mysterious features located beyond Neptune. We are specifically talking about the Kuiper belt, a huge donut-shaped region filled with icy debris left over from the formation of the solar system, including comets and dwarf planets like Pluto. What happens is that the 6 farthest objects in the Kuiper belt exhibit elliptical orbits that are all oriented in a similar direction within physical space and tilted approximately 30 degrees downward relative to the orbital plane of our 8 known planets. What's strange here is that, despite their distinct orbital velocities around the solar system, they maintain this alignment. The likelihood of such alignment occurring randomly is extremely low, around 0.007%. So, here comes Planet 9, a hypothetical massive celestial body that offers a plausible explanation for this strange phenomenon, potentially exerting gravitational influence to shape these orbits. The initial theory didn't hold up for long, facing accusations of observational bias and calculation errors. Then, in 2017, another study popped up, sparking back the idea that maybe Planet 9 is out there after all. This time, Spanish astronomers tried a novel approach, focusing on observing extreme trans-Neptunian objects. These celestial bodies orbit the Sun in highly stretched elliptical paths, with average distances exceeding 13 billion miles. The research suggests that the distances between these objects' nodes and the Sun might provide clues to Planet 9's location. You see, these nodes are the points where a celestial body's orbit intersects the solar system's plane. When these objects reach these points, they're more likely to interact with other solar system bodies, potentially causing significant changes in their orbits or even collisions. So, if the trajectory of these extreme trans-Neptunian objects remains stable, everything's fine. But if it's not, well, that's a sign that something else, something big, is messing with their path. And that's exactly what the research found. There is something unseen out there, throwing these objects off course. And that something could be a planet, chilling at a distance between 300 to 400 times farther from the Sun than Earth. To this day, the study of the extreme trans-Neptunian objects is the strongest evidence we've got for Planet 9's existence. And if you're still not convinced by this theory, know that strange motions like these have led to planetary discoveries before. Neptune, for instance, was spotted because Uranus's motion didn't quite agree with the predictions of Newtonian gravity. But the deflection of its orbit could be explained if it was caused by a pull of an undiscovered planet. And just like that, we discovered Neptune. Now, the year is 2021, and there's all this buzz about Planet 9 again. After correcting some old guesses, studies are now leaning towards the idea that this mystery world follows an epic loop around the Sun every 7,000 years. That is massive news, because it means this planet might be closer than we ever thought, making it easier for our telescopes to spot it. The paper also suggests there is a whopping 99% chance that the funky orbits of these distant objects are all because of this unseen planet, not just some cosmic coincidence. Now, the odds of this whole situation being a fluke are down to a 1 in 250 chance, which is much better than the 1 in 10,000 chance back in 2016. All these optimistic numbers have brought us to where we are today, keeping our hopes and working on better equipment to continue the mission of spotting Planet 9. As mentioned earlier, researchers in Hawaii created some kind of treasure map utilizing the Panoramic Survey Telescope and Rapid Response System to eliminate 78% of its locations. This is great news, considering how challenging it is to find a planet-sized needle in a cosmic haystack. But unfortunately, Planet 9's presence remains a ghost in the dark outer reaches of our solar system. Enthusiasts are still convinced of its existence and believe it is only a matter of time before we celebrate the discovery of Earth's new cosmic cousin. They're putting their hopes on the Vera Rubin Observatory, which is currently under construction in Chile and is scheduled to begin science operations in late 2025. Over the course of 10 years, this observatory will scan the entire southern hemisphere sky every few nights with a 27-foot, fast-moving telescope equipped with the largest digital camera in the world. The idea is to catalog everything in the solar system, reaching out to and beyond Neptune, and tracking the movements of millions of celestial objects, including space junk, asteroids, comets, and stars. If Planet 9 is indeed out there, this next-generation telescope could be the one to find it. The existence of this mysterious planet is far from being universally accepted in the scientific community. That is simply because Planet 9 isn't the only explanation for the strange phenomenon occurring beyond Neptune. One theory suggests that a group of distant objects, such as dwarf planets, comets, and moons, might be collectively influencing the orbits of the extreme trans-Neptunian objects. Others believe that a black hole is behind all this. These compressed masses are some of the densest objects in the universe, potentially capable of affecting the orbits of other masses, like how this supposed ghost Planet 9 is believed to be doing. Another bold perspective suggests that our current understanding of the laws of gravity is flawed, actually incomplete. This theory, known as modified Newtonian dynamics, proposes that these distant icy objects exhibit strange behavior not due to influence from another planet, but rather because the immense gravitational field of the Milky Way is influencing them. However, Even supporters of this theory acknowledge that it is too early to draw firm conclusions, and much more extensive research is still required. While we continue our relentless hunt for Planet 9, some astronomers have taken it a step further, suggesting the existence of a hypothetical Planet 10. This world has a mass and size like that of Mars or Earth and is located on the edges of the Kuiper belt. But the thing is, if this alleged Planet 10 is indeed as small as scientists believe, it might not have enough gravity to clear its orbit of debris. And that is pretty similar to what happens with Pluto, being one of the reasons why it got into trouble back in 2006. So yeah, it's better not to get too excited. This supposed Planet 10 might end up classified as another dwarf planet.
Look at this giant donut-shaped region far away from Earth, beyond the orbit of Neptune. We're talking about a distance of more than 2.5 billion miles. It's the Kuiper belt, and something eerie and bizarre is happening there. Dwarf planets and other small objects dwelling there refuse to cluster together. Instead, they follow particular orbits, which is weird. The reason might be a large, mysterious planet hiding beyond Pluto. Its gravity might be messing up the orbits of those Kuiper space bodies. Hear me out. Our solar system is made up of the Sun and everything that goes around it because of the star's strong gravity. This includes the 8 main planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. There are also smaller things like moons, asteroids, and Pluto. For a long time, people thought Pluto was the 9th planet, but when it was reclassified as a dwarf planet, scientists started looking for a new Planet X. Did they have a thing about odd numbers or what? And guess what? Some really think there might be a big, icy planet hiding far, far away beyond Neptune. This mystery planet is often called Planet 9. Now, Planet 9 hasn't been seen yet, but scientists think it might be out there because of some tiny, faraway space rocks called etnos that move following bizarre, confusing paths. These paths seem to be grouped together and tilted in a way that doesn't happen by chance. This could mean there's a hidden planet pulling them into place with its gravity. If Planet 9 is real, it might be 5 to 10 times heavier than Earth. It would also be super far away, hundreds of times farther from the Sun than Earth is. Over the years, scientists have guessed different distances for its orbit, and the newest guess in 2025 says it could be about 290 times farther from the Sun than Earth. There are some cool ideas about where Planet 9 came from. It might have started as a big planet that Jupiter once kicked out of the inner solar system, or it might have come from another star or even wandered around space on its own before getting caught by the Sun's gravity. Even though scientists have looked really hard using powerful telescopes, no one has actually seen Planet 9 yet, and so far, its existence is still just a theory. But recently, a group of researchers tried something clever. They used data from 2 special space surveys called ERAS and ACARI. These 2 looked at the sky in invisible light, far infrared, about 23 years apart, which is helpful because Planet 9 is supposed to move very slowly. The team focused on a special list from ACARI, which is better at finding faint, moving things in space. They guessed how bright Planet 9 might be and how fast it might move based on how big, far away, and cold it could be. Then they looked for matching blips in the sky that were seen by both ERAS and ACARI, but not in the exact same spot. That's because a real planet would have moved a little over 23 years, and they indeed found 13 possible matches that could be Planet 9. Their estimations were based on how far away the object seemed to be, 500 to 700 times farther from the Sun than Earth, and how heavy it might be, which is 7 to 17 times Earth's mass. After looking very carefully at all the images, they narrowed it down to one really good candidate. The 2 detections weren't in the same spot in both surveys, and the way they appeared in the Akari map matched what you'd expect from a slow-moving object. It showed up on one date and wasn't there 6 months earlier. But of course, there was a catch. Apparently, the old data isn't good enough to figure out the exact path of the potential planet. So, the team wants to do new follow-up observations using a special camera called DCAM, which is really good at spotting faint, moving objects. That way, they can find out if this candidate is really Planet 9. Additionally, it can help us learn more about how our solar system works and how it formed. If Planet 9 is ever discovered, it would totally change the way we understand our solar system. It could explain why some far-out space rocks in the Kuiper belt tilt weirdly. The thing is, most planets go around the Sun in a flat-ish circle, but those faraway objects are tilted about 20 degrees. Planet 9 might be the reason why. Next, we'd probably find out why those tilted objects seem to point the same way. Their orbits are grouped together in one direction. A big hidden planet's gravity could be hurting them like sheep. There are also some strange tilted objects super far away. They don't make sense unless something big, like Planet 9, is tugging on them. A few space rocks orbit the Sun backward between the big planets, which is kinda the wrong way. That's super weird unless something big is messing with them. Some far-out Kuiper belt objects keep crossing Neptune's path and haven't been flung away. That's because Planet 9 might be helping keep their orbits stable over a long time. Another cool thing is that if Planet 9 existed, it would be a super-Earth, a kind of planet we see a lot around other stars, but we don't have in our solar system yet. So finding one here would make our solar system more like the others out there. Throughout history, people have been wondering if there could be hidden planets far beyond Neptune, even before Pluto was found. Back in 1880, a guy named George Forbes guessed there might be 2 unknown planets way out there, one about 100 times farther from the Sun than Earth, and the other about 300 times farther. He thought these mystery planets might be pulling on some comets and changing their orbits, kind of like how Jupiter does with the comets near it. In 2004, scientists found a weird little world called Sedna. It had a strange path around the Sun that didn't seem to be affected by any of the known planets. Its closest point to the Sun, called perihelion, is way too far for Neptune to be the reason. This made some scientists wonder if Sedna got pushed into its path by a hidden planet, maybe even something as big as Earth or bigger. Others thought maybe it was a star that flew by a long time ago, or another star that formed near ours. Then, in 2014, another odd object was discovered. It had a very similar orbit to Sedna, which made people even more suspicious that there could be something big out there messing with their paths. This kicked off a new round of the Planet X or Planet 9 hunt. At a meeting in 2012, a scientist named Rodney Gomez said that maybe there was a big, hidden planet around 1,500 times farther from the Sun than Earth. He thought it could explain the orbits of other odd objects, like some far-out comets and centaurs, small bodies that wander among the giant planets. At that time, those who supported the Planet 9 theory believed that if it existed, it would move around the Sun in a huge, stretched-out circle called an elliptical orbit. It would be about 400 to 800 times farther from the Sun than Earth is, about 13 to 26 times farther than Neptune. If it really had that kind of orbit, it would take around 10,000 to 20,000 years to go around the Sun just once. Plus, if it indeed orbited the Sun, it wouldn't follow the same flat path as the other planets. Its path would be tilted by about 15 degrees to 25 degrees. The farthest point in its orbit, called aphelion, would be in the direction of the Taurus constellation. As for the closest point, it would point towards Serpens, Ophiuchus, or Libra. As for the composition of Planet 9, it would probably be a lot like Uranus or Neptune. It would have a thick atmosphere made of hydrogen and helium, and it would be super cold, -375 degrees Fahrenheit. Its core would be made of iron and its middle layer would be full of rock and water ice. At the same time, if the planet was smaller and denser, then it might be more like Earth, with a rocky surface instead of a gassy one. According to a scientist named Mike Brown, if Planet 9 was real, a space probe would reach it in about 20 years if we used a powerful slingshot path around the Sun.
A new super-Earth has been spotted by astronomers, and it's quite intriguing. This planet, called TOI 715b, is about 1.5 the size of Earth, which is why it's called the super-Earth. It's also relatively close to us in space terms, only 137 light-years away. For comparison, most exoplanets are hundreds of light-years away, and all the interesting stuff, like black holes and nebulas, are usually more than thousands of light-years away from us. So, could it be habitable? The habitable zone is an estimate of where a planet might have the right conditions for liquid water. This is what we call some distance from the star, where the temperatures on the planet should be okay-ish, and water should stay liquid on its surface. It's not super precise, because it depends on a bunch of factors like the type of star, how reflective the planet is, its size, and so on. Also, just being in this zone isn't enough for water to actually be there. The planet also needs the right kind of atmosphere and a few other things. So, we invented a stricter definition in 2014, the conservative habitable zone. It's a more precise term defining the best candidates that have liquid water. Otherwise, we get too many potentially habitable planets that are not actually habitable at all. The CHZ is based on how much energy a planet gets from its star compared to Earth. If a rocky planet gets between 40 to 85%, it's considered to be in the CHZ, no matter how far away it is from its star. These planets have a higher chance of being habitable. And yes, TOI 715b is located there. This super-Earth orbits the M-type star, also called red dwarf. It's a star that's much smaller and cooler than our Sun, about a quarter of the Sun's size and mass. But if the planet is located in the habitable zone, it's actually a better option for life. Red dwarfs live much longer than our Sun, a yellow dwarf. This also means that they have more time to form little creatures on their planets. And this red dwarf really is older than our star. Our Sun is 4.6 billion years old, and this star is 6.6 billion years old, give or take a few hundred million. It doesn't have much magnetic activity, so it's not dangerous. It doesn't flare up like younger red dwarfs. These flares can be super strong and might even hurt planets by taking away their atmospheres. Although some planets around it do have thinner atmospheres, it seems like this red dwarf has already gone all out. These red dwarfs are where we're looking for planets that could support life right now. Our super-Earth is really close to its star, zooming around it in just 19 days. Since the star is small and the planet is so close, the planet passing in front of its star happens a lot and looks really clear. This makes it easy for telescopes like the James Webb to study its atmosphere without needing too much time. Now, speaking of the James Webb Space Telescope, it's bringing us into a new era of understanding distant planets beyond our solar system. Imagine being able to see what gases make up the air on a planet millions of light years away. James Webb will help us to find worlds that could support life. Right now, it's trying to figure out whether TOI 715b has an atmosphere. If it does, its atmosphere might be easier to spot compared to a planet that's drier and denser. And then we might get even more height because it would look like a good place for life. On top of all that, there might be another planet in this system, also in the habitable zone. We're not sure whether it's really there, it's just a candidate with a crazy name. But if it turns out to be real, it would be about the size of Earth. Also, it would be the smallest planet in the habitable zone ever spotted by the TESS telescope. Now, another cool thing about TOI 715b is that it cannot just have water on it, but be an entire water world. An ocean planet is a type of planet that has an ocean covering its surface or has subsurface oceans. They might not have much dry land, because the water can cover everything. Sometimes the entire planet can be covered in other liquids, like lava or ammonia. When it comes to planets outside our solar system, we can't see surface water directly with our current technology. Instead, scientists look for water vapor in the atmosphere as a hint there might be liquid water below. And of course, we wonder if these planets can have life, hopefully not in the form of Leviathan-like monsters. Our models show that planets with oceans might be pretty common in our galaxy. This means there could be lots of ocean worlds out there waiting to be discovered. But the most important part about TOI 715b is that it's in the so-called small planet radius gap. If we give the planets a lineup, there will be those that are bigger and smaller than Earth. But there's a sudden gap in planets that are about from 1.5 to 2 times bigger than ours. Where are they? This gap is interesting to scientists because it tells us something about how planets form and change over time. It's not that planets don't form in this size range. They actually start off larger and then lose some of their mass, like a balloon gradually deflating. Perhaps it happens because of how they orbit their stars, with stars blowing away some of their mass as they dance around it, as our Sun does with gas from comet tails. This gap holds a lot of mystery, and planets, like our new super-Earth, are clues that could help us unravel it. We aren't sure whether it exists around red dwarfs. Maybe it's a gap in how dense these planets are, rather than in their actual size. So studying our discovered planet is even more interesting. It'll help us learn more about distant stars and their planets. Now, I mentioned TESS a while back. NASA's TESS, Transiting Exoplanet Survey Satellite, has been in space for 6 years now and has been incredibly successful. NASA launched TESS because we already found over 5,000 planets orbiting other stars, mainly thanks to the Kepler telescope. But Kepler mostly found large planets, not necessarily like Earth. We decided to focus TESS on finding smaller Earth-like planets around nearby bright stars, making them easier to study with future telescopes. Here's how it works. The camera observes stars and looks for changes in their brightness. If the brightness suddenly drops for a while and then gets back, it could mean there is a planet passing in front of it. But stars can dim for other reasons too. For example, flaring up or having dark spots on their surface, which is why we need to be careful with this data. TESS shows us the size and orbit of these planets. Then ground telescopes help determine their mass. With these 3 parameters, we can figure out what the planets are made of and if they're rocky like Earth or gassy like Jupiter. Yeah, you want to avoid Jupiter after taco night. One example of TESS's discoveries was the TOI 700 system. There, it discovered its first ever Earth-like planet, TOI 700d. This exoplanet also orbited a red dwarf, and it's even closer to us, about 100 light-years away. Unfortunately, it's unlikely to be habitable because the temperatures there are crazy. Another big discovery was made in the AU microscopy system. TESS discovered a planet about 4 times the size of Earth and another nearly 3 times Earth's size. This system has become a key area for studying how stars and planets form and change over time. TESS has also spotted a variety of other exciting finds, including supernova, hot worlds, and so on. And as it enters its 6th year, we can only expect more exciting findings to come.
Have you heard about Planet 9? No, not Pluto. We're talking about something lurking on the outskirts of the solar system. A mysterious planet that exists in our solar system that we haven't yet discovered. We've been looking for it for years, but finally, it seems like scientists found a key to solve this mystery. Planet 9 is a hypothetical planet. Astronomers have been on the hunt for it for quite some time now. But it's so elusive that they've only been able to piece together a few details about its potential characteristics. One thing we do know is that Planet 9 has to be a massive world, possibly up to 10 times the mass of Earth. That's one big planet. It's also thought to be a distant wanderer, hanging out somewhere between Neptune and Pluto. Some scientists think that Planet 9 might actually be a mini Neptune with a thick, gaseous atmosphere and a rocky core. Others speculate that it could be an icy world with a solid, frozen surface and a thick layer of hydrogen and helium gas. Of course, since we haven't actually found Planet 9 yet, we can't say for sure what it's like. We're not even sure that it even exists. Some say it's just a myth, like the Tooth Fairy or the Easter Bunny, but others are convinced that it's out there somewhere. And at the end of the day, we're not entirely sure if Planet 9 is even a planet. It might be a special kind of black hole or made entirely of dark matter. The search for Planet 9 began in the early 21st century when a group of astronomers realized that something wasn't quite right with the outer reaches of our solar system. They noticed that some distant objects, known as trans-Neptunian objects, were behaving in unexpected ways. Trans-Neptunian objects, or TNOs, are like the cosmic version of those items in the back of your fridge that you forgot about for years. They're small, icy bodies that hang out in the Kuiper belt, beyond Neptune. So, scientists noticed that these guys started behaving weirdly. At first, they thought it might be a fluke. But as they dug deeper, they began to suspect that there was a ninth planet lurking out there. Why haven't we discovered it yet, you ask? Well, it may be because of Planet 9's weird orbit. All the other 8 planets orbit the Sun in roughly the same plane, which is like a flat disk. However, our hypothetical friend's orbit is different. It might be tilted and move in a different direction compared to the other planets. Its orbit might also be stretched out like an oval, rather than being nearly circular like usual. Because of this, Planet 9 might spend most of its time far from the Sun, like a true introvert. It only comes relatively close to the inner solar system every few thousand years. This would make it super faint and hard to spot. So the only way we may discover it is by studying the gravitational effects it has on our solar system. And this isn't the first time astronomers have gone looking for a new planet. Back in the 19th century, there was a similar hunt for a hypothetical Planet X. But this time, they were armed with much better technology and a much better sense of humor. They began calling their elusive quarry Planet 9, which was much catchier than Planet X. They even came up with a hashtag for the search, Pluto Lives. It was a reference to the fact that Pluto had been kicked from the planet gang and some astronomers were eager to find a new planet to take its place. But the search for Planet 9 has been no easy task. It's like trying to find a lost sock in the laundry basket the size of a football stadium. It's so far away and so faint that even the most powerful telescopes can't see it. Instead, astronomers have had to rely on indirect evidence, like the strange orbits of TNOs, to try to figure out where it might be. Some scientists have even supposed that it might be a wandering rogue planet, which would explain why it's so hard to find. But they haven't given up hope. Till this day, they're scouring the skies using all sorts of high-tech telescopes and fancy algorithms to try and spot this elusive planet. And fear not, dear curious human, because it looks like after so many years of research, we may have finally found the key to solve this mystery. Astronomer Man Ho Chan from Hong Kong has a theory. He believes that Planet 9 could have a bevy of moons. That's right, not only is it a giant planet hiding out in the depths of space, but it's also a bit of a hoarder. Moons are all the rage in the outer solar system. In fact, almost every planet here has at least one moon, except for Mercury and Venus. Earth has just one, which is kind of sad if you think about it. Even non-planetary bodies like Pluto have at least a couple of moons. A bit unfair, isn't it? Anyway, taking this into account, let's go moon picking with Planet 9. The region between the rock-filled Kuiper belt and the rock-filled Oort Cloud where this planet is predicted to be, should be ripe for the picking. Chan made some calculations and determined that it would be stranger if the elusive planet didn't have any satellites. According to his calculations, an object the mass of Planet 9 should capture at least 20 TNOs as large as almost 90 miles across. It's like our mysterious planet is playing cosmic Pokemon with these guys. So, what if Planet 9 has moons? Would that make any difference? Kinda, yes. They could give us some indirect clues to finally locate this mysterious planet. Now, you might be thinking, how in the cosmos can we possibly spot these teeny tiny moons? It's not like they're going to wave a giant flag or blast some Beyoncé tunes to get our attention. Well, apparently the key lies in something called tidal heating. Tidal heating might sound like a new workout trend, but it's a real scientific phenomenon. It happens when two celestial bodies are close together. You see, tides aren't just about the rise and fall of the ocean, they're also the result of gravity pulling unevenly on a planet or moon. When a planet and a moon are close enough to each other, their gravity pulls on each other, creating a bit of a football shape. And as these celestial bodies move around each other, they shift shape and generate friction inside, which produces heat. Wow, who knew that Planet 9 could have a workout routine? Perhaps we should start calling it Gym Planet instead. Anyway, if Planet 9 has any moons, the gravitational pull from these moons would cause it to change shape constantly, generating heat in the process. And we might be able to detect this mysterious planet through the heat produced by those moons, even though it gives off no other signals. Now, before you get too excited, finding them won't be a walk in the park. They're incredibly small and would be very far away from us. But hey, nothing worth discovering ever came easy, right? Scientists are optimistic that with the right technology, they can spot this telltale sign. It will be easier for us to spot them with fancy instruments like modern telescopes. Talk about cool friends to have, right? Sure, the process of finding it may be difficult and time-consuming, but the potential payoff is huge. Finding this planet could explain a lot of the strange behavior observed in TNOs, the Kuiper belt, and beyond. As we've already mentioned, they've been acting super weird lately, tilting and aligning in suspicious ways. If this planet doesn't actually exist, we have yet to explain what is the reason for this strange behavior. In any case, the search for Planet 9 is one of the most exciting and intriguing quests in modern astronomy. It's like a cosmic scavenger hunt, and everyone's invited to join in on the fun. So, grab your telescopes and let's go planet hunting. Who knows, maybe we'll find it sooner than we think.
Recently, the James Webb Space Telescope has unearthed a mysterious ancient galaxy, and it might completely change our understanding of the nature of dark matter and the process of galaxy formation. The telescope has managed to spot a stellar population bigger than our home Milky Way galaxy from 11 billion years ago, and it shouldn't actually exist. This galaxy is massive and is home to extremely old stars. They formed in the early universe. The problem is that this new observation upends our current cosmological models, since, by the time of the galaxy's birth, not enough dark matter had built up to seed such a formation. Researchers have been chasing this particular galaxy for 7 years. They spent endless hours observing it with the help of the two largest telescopes on our planet to figure out how old it was. Unfortunately, it was too faint and too red, so no one could measure it. Only after scientists moved their observations to space and started using the James Webb Telescope did they manage to confirm the nature of the galaxy. The thing is, unlike the Hubble Space Telescope, which orbits around Earth, James Webb moves around the Sun 1 million miles away from Earth. That's why it made it possible to see the galaxy clearer. Previously, astronomers were sure that in early cosmic times, there were very few huge galaxies. But recent findings challenge these theoretical models. Extremely massive dormant galaxies have been discovered as early as 1 to 2 billion years after the Big Bang and the beginning of the universe. The scientist who led the spectral analysis of the James Webb Telescope data said that they were doing everything possible to confirm the oldest galaxies that existed deep in the universe. When they did, it pushed the boundaries of the current understanding of how galaxies form and evolve. And now, the main question is, how they managed to form so fast in the early universe, and what enigmatic mechanisms made them stop forming stars all of a sudden, while the rest of the universe was still doing so. Galaxy formation is largely dictated by the concentration of dark matter. You see, around 84% of matter in the universe doesn't emit or absorb light. Astronomers call this stuff, which can neither be seen directly nor detected by indirect means, dark matter. It supposedly affects visible matter, radiation, and the very structure of the universe. Finding extremely massive galaxies so early in the universe is posing serious challenges to our standard model of cosmology. All because astronomers don't think that such monstrous dark matter structures as the ones hosting those massive galaxies had enough time to form. Researchers need more time to figure out how common such ancient galaxies are and how massive they can be. But if they manage to find more of those, it will really upset our ideas of galaxy formation. But it could improve our understanding of the physics of dark matter. Bizarre ancient galaxies aren't the only thing discovered thanks to James Webb. For example, scientists have long suspected that supermassive black holes could have existed in the early universe, and this theory has been proven only thanks to the JWST and its infrared eye. It showed that an ancient black hole within galaxy Sears 1019 was actively munching on all the matter it could lay its hands on. This hole is from the times when our universe was less than 600 million years old. And that's another mystery we're yet to crack. It's supposed to take way longer than 600 million years for a supermassive black hole to grow to its full potential. Astronomers were watching the galaxy hosting the unusually old black hole as part of the Cosmic Evolution early release science survey. They saw the galaxy as it was when our 13.8 billion-year-old universe was just 570 million years old. Besides the ancient black hole, scientists spotted two other ones. Those probably appeared 1 and 1.1 billion years after the Big Bang. They also discovered 11 ancient galaxies that existed between 470 and 675 million years after the beginning of cosmic history.
Hundreds of diplomatic spaceships take off from Earth and head into space. When they reach their destination, they're met by hundreds of alien ships. This is humanity's first contact with an extraterrestrial civilization. People managed to detect them not so long ago, in a star system very close to our home. It's Proxima Centauri. This red dwarf star is the closest to our solar system. It's 7 times smaller than our Sun, which makes it only 50% bigger than Jupiter. Proxima Centauri is also 8 times as light as the Sun. This star system is 4.2 light-years away. That's how long it takes a photon of light to travel from this star to Earth. By comparison, it only takes 8 minutes for sunlight to reach our planet. If you decided to travel to Proxima Centauri, it would take you about 73,000 years to fly there in a conventional rocket. That's longer than our intelligent civilization has even existed. But it's not the star itself that interests us, it's the planet orbiting it. That's Proxima Centauri b. It's 17% bigger than Earth and about 10% heavier. It orbits its star at a distance of 4.5 million miles. By comparison, Earth is 93 million miles away from the Sun. That's 20 times farther. But the host star, Proxima Centauri, is a red dwarf. It doesn't emit as much light and heat as our Sun. So the planet Proxima Centauri b is right in the habitable zone of the star. It's located at such a perfect distance from its mother star that the planet neither gets too hot nor turns into a block of ice. In other words, the temperature there makes it possible for water to exist in its liquid state. This means that Proxima Centauri b could host life. But further observations of the planet make it doubtful. The host star is very unstable. Its brightness changes too frequently. In 2017, astronomers witnessed a catastrophic flash. The star increased its brightness by 1,000 times for 10 seconds. Before that, there was another weaker flash. The planet received an enormous amount of radiation. If there had been life there, that flare would have wiped it out completely. Overall, Proxima Centauri b receives about 400 times more X-rays than Earth. Complex living organisms cannot live under such conditions. Scientists say that even if there was an atmosphere and an ocean on Proxima Centauri b, this constant radiation would simply blow them off the planet. Proxima Centauri b is so close to its host star that it's gravitationally locked to it. This means that the planet is always turned to the star with only one side, just like the moon is turned toward Earth. That means that only one side of the planet receives this awful amount of radiation, and some experts speculate that an intelligent civilization might live on the night side of the planet. And it could be this civilization that sent us the strange signal that astronomers caught in 2019. Scientists described it as, quote, a bright, long-duration optical flare, accompanied by a series of intense, coherent radio bursts. This radio signal was observed for 30 days by one of the radio telescopes on Earth. Scientists thought the signal was artificial and could have been sent by an extraterrestrial civilization. Presumably, the signal came from Proxima Centauri b, or one of the moons that might be in that star system. But further observations failed to detect the signal. Now, the main theory claims that this radio signal is just some kind of interference from some technology on Earth. But what if it was really sent by a civilization living on the dark side of Proxima Centauri b? Well, we may soon find out for sure. People are launching a brand new telescope into space. It's the James Webb Space Telescope. It's scheduled to be launched at the end of 2021. A booster rocket will take off from Earth and reach orbit. Then, it'll deliver the telescope to a specific point between our planet and the Sun, where their gravitational forces are roughly equal. Plus, there's no light pollution in space, unlike on Earth's surface. There are also no clouds or other weather conditions that might interfere with the telescope. The James Webb Space Telescope will replace the Hubble telescope, which has been operating in space since 1990. The new telescope costs $9.8 billion. And here's why. It'll use a mirror as wide as a boxing ring. This will allow the telescope to see very far into space. So far, in fact, that the light from some events happening there won't have reached Earth yet. This means we will literally be able to look back in time. The James Webb Space Telescope will see the universe almost immediately after the Big Bang. We'll see how the first stars and galaxies were born, and how the universe turned into what we observe today. But also, this telescope can be used to examine Proxima Centauri b. Astronomers will be looking for artificial light there, like the LED lights we have on Earth. If Proxima Centauri b really hosts life on its night side, then the locals must have learned to transfer heat and light from the day side of the planet, and they would have to use artificial light to support life on their side. The James Webb Space Telescope is powerful enough to distinguish the light waves emitted by the star from those that might be created by someone on the dark side of the planet. And if we do detect some artificial light, we'll have the first ever confirmation that an intelligent civilization might exist outside our solar system. But there's always room for error in calculations and data interpretation. The only way to establish the truth once and for all is to send a space probe to Proxima Centauri. Then we can get real pictures of the planet. The main problem is distance. Although Proxima Centauri is the closest to the Earth star system, it still takes tens of thousands of years to get there. After all, the Voyager 1 space probe needed about 44 years just to leave the solar system. And that's just a small step compared to the actual distance to the nearest star. So we need other methods of travel, and they have to be much faster. Some scientists want to send microprobes to Proxima Centauri b. They won't be any heavier than a sewing needle. A launch vehicle will deploy about 1,000 of these probes into orbit. Then they will unfold a space sail. This is an ultralight material that will use the power of light to create thrust. When the sail is deployed, we'll focus a powerful laser beam onto it. This will accelerate the probes to about 20% of the speed of light. This will be an absolute speed record by our standards, but it'll still take about 21 years for these probes to reach their destination. And we'll have to wait for about 4 more years just to get the first signal from them. The Proxima Centauri star system isn't the only potential world to host life, and one of the tasks of the James Webb Space Telescope is to look out for other worlds. The telescope's powerful instruments will allow it to find relatively cold planets where temperatures are close to those on Earth. We'll be able to study in detail around 24 nearby star systems, and we'll be able to detect not only planets themselves, but also their moons. Scientists expect a boom in the discovery of exoplanets. From the start of the telescope in 2022, we'll constantly be detecting new worlds and learning more about those already discovered. The James Webb Space Telescope will allow us to better study our own solar system. Jupiter's moon Europa, for example. Scientists believe there might be water there. Although Europa looks like a block of ice, the moon's gravitational interaction with Jupiter heats its core. That likely makes the ice deep below the surface melt. So there's likely to be an ocean under the ice crust. Similar conditions could exist on Enceladus, Saturn's moon. This moon is geologically active. There are geysers that burst out of the cracks on the moon's surface. The James Webb Space Telescope's infrared instruments will be able to explore Europa and Enceladus in search of biosignatures. Those are the traces of life activity of living organisms or bacteria. This telescope is scheduled to operate for about 6 years, but in the future, we'll launch an even bigger one. It's called LUVOIR, which stands for the Large UV Optical Infrared Surveyor. Its mirror will be twice the size of that of the James Webb Space Telescope, and almost 7 times the size of the Hubble's. The telescope is scheduled to be launched in 2039. We'll get it into orbit with the help of a super heavy rocket. Then we'll have to deliver the telescope to its destination, 1 million miles away from Earth. And then it'll begin its observations. We could learn to travel faster than the speed of light by that time. Then, if we find a potentially habitable planet with the help of the telescope, we can send a space probe, or even a team of explorers there. In this case, a diplomatic meeting with an extraterrestrial civilization might become a reality.
This is the James Webb Space Telescope, and this is how far we can see through its eyes. Impressive. But let's zoom further. Further! Further! The image is getting blurrier and blurrier. Wait! What is this shadow? It's a giant telescope capable of seeing those seemingly blurry images in perfect detail. NASA's Roman telescope is to be launched in 2027, and it might help us unravel the mysteries of the universe, including the essence of dark matter. No worries, James Webb will continue to show us the beauty of the cosmos and solve mysteries one by one. But astronomers have a new mission these days. They want to deploy the next, even bigger space telescope, and this mission is already well underway. The Nancy Grace Roman Space Telescope is likely to start a new age for astronomy. Scientists hope that the telescope will gather more data than any other NASA mission has ever done. Hubble and Webb are incredibly good at zooming in to get a clear, detailed view of small parts of the sky. Meanwhile, Roman is going to provide us with a much wider field of view. It will be capable of creating infrared images 200 times larger than Hubble. At the same time, it will have a similarly high level of detail. But even though the new telescope will be able to produce perfect images, it's going to be used mainly for surveys. Let's say we need to look for the star population in a nearby galaxy. But it's a too large field of view for Hubble. If we use it, we'll have to stitch lots of different shots and create mosaics out of them. But with Roman, a picture of the entire galaxy can be taken in one single shot. Look at this recent mosaic of our neighbor, the Andromeda Galaxy. This image was put together using 400 individual images taken by Hubble. And Roman will paint the same ultra-vast picture with the same level of detail with just 2 images. It not only sounds cool, it also means an unprecedented amount of data collected. Once we have such a panoramic view of the universe, NASA and other space agencies will probably be able to answer some of the greatest questions that have been intriguing humanity for ages. One of the main goals is to test the theory of relativity suggested by Albert Einstein. It's been well tested on the scale of our solar system, but not so much on larger cosmological scales. According to this theory, visible matter is supposed to slow down the expansion of the universe. But the universe is expanding non-stop, and doing it faster and faster. So, astronomers attribute this ever-growing expansion speed to a mysterious component, dark energy. They believe that it makes up around 68% of the universe. Hopefully, Roman will provide us with data that will help us accurately measure the position and distance between us and millions of galaxies. Eventually, it might let us figure out the expansion rate of the universe in different areas. In the end, the results might tell us whether Einstein's theory of gravity needs modification. One more of Roman's main goals is to detect hundreds and thousands of new exoplanets within our home Milky Way galaxy. The telescope will be able to do it using the technique known as gravitational microlensing. You see, when two stars align with each other, the one positioned in front distorts and magnifies the light of the other star located behind. And if the star in the foreground has a planet, we can see how this planet affects the light of the star behind it. Roman will hopefully count billions of stars, providing us with a very good census of how many of these stars have exoplanets. The cutting-edge telescope will not only spot new exoplanets, it will also carry another crucial instrument called a coronagraph. It can image exoplanets that are close to their parent star. This is actually an extremely tricky technique since the starlight has to be suppressed. After all, it's much brighter than the objects you want to study. By those objects, I mean nearby planets. The chronograph on the Roman telescope will try to capture large Jupiter-like planets directly by conducting live corrections to improve the quality of images. If it proves to work properly, the telescope will make a great demonstration instrument, forming the baseline for the technology that will be used on future space observatories. Such observatories will be capable of directly capturing Earth-like planets in the habitable zone of their parent stars. But the Roman Space Telescope isn't the only project that can change the way we explore space. There are other concepts, like Nautilus. It's an idea of a revolutionary space telescope based on a novel technology: special optical elements. Such elements can potentially allow us to overcome the main limitations of space telescopes: non-scalable primary mirrors. The Nautilus technology can provide large but ultra-light telescope apertures, enabling the launch of a massive fleet of identical telescopes. They will have an impressive light collecting power, which will help Nautilus survey thousands of Earth-sized planets located in the habitable zone of their stars. As a result, we might find atmospheric signatures of life on those planets. Over the past 2 billion years, the atmosphere of our planet has changed dramatically. The abundance of free molecular oxygen and ozone, which are highly reactive gases, together with water vapor and methane, represent a unique atmospheric composition. The presence of these gases, biosignatures, in the atmosphere of our planet is a sign of life that can be detected from afar. We're speaking about galactic distances here, but to identify such fingerprints of atmospheric components in the light reflected by or transmitted through the atmospheres of Earth-like planets, we need very large telescopes. NASA's Kepler mission has discovered more than 4,000 planets. And still, no existing, or even planned, space telescope has a diameter that is large enough to search for life in exoplanets' atmospheres. Finding and interpreting observations of extraterrestrial life correctly is very difficult. But the Nautilus team hopes to build a telescope capable of studying thousands of Earth-like planets. Then, there's the European Space Agency's Euclid mission. It's designed to explore the composition and evolution of the dark universe. The mission was named after Greek mathematician Euclid, who lived in Alexandria around 300 years BCE. He founded the subject of geometry, and since the density of energy and matter is tightly linked to the geometry of the universe, the mission was named in his honor. This space telescope will create a great 3D map of the large-scale structure of the universe across space and time. It'll do it by observing billions of galaxies across more than a third of the sky. Euclid will try to figure out how the universe has expanded and how its structure is formed over the course of cosmic history. Hopefully, it will reveal more about the role of gravity and the very nature of dark matter and dark energy. As we already know, dark energy likely accelerates the expansion of the universe. As for dark matter, it controls the growth of cosmic structures. But experts remain unsure about what dark energy and dark matter are. By observing the evolution of the universe over the past 10 billion years, we might finally figure out how it has been expanding and changing. From this, astronomers might infer the properties of dark energy, dark matter, and gravity. It could help find out more about their precise nature. The Euclid spacecraft is around 15 feet tall and 12 feet wide. It consists of two main components, the payload module and the service module. The payload module includes a 4-foot diameter telescope and two scientific instruments, a visible wavelength camera and a near-infrared camera, or spectrometer. As for the service module, it contains satellite systems, such as electric power generation and distribution, data processing electronics, thermal control equipment, and so on.
During the recent years, scientists made two breakthrough discoveries about our universe. Thanks to new technologies, we've looked into the distant past. And we've learned something that can change our understanding of the universe forever. What are these discoveries and what do they mean to us? Let's find out. Recently, we unveiled the first color image from the James Webb Space Telescope. It's a mind-bending photo capturing thousands of ancient galaxies. This oldest documented light in the history of the universe dates back over 13 billion years. That's just 600 million years after the Big Bang. It's like getting a sneak peek into the universe's baby album. But that was just the beginning. Astronomers were expecting to see some tiny young galaxies. But what they found was a real surprise. Impossibly early, impossibly massive, and all that from just a tiny red dot. The lead author of the study, Ivo Laba, was working at the computer as usual, and suddenly he got two numbers. Age, 13 billion years. Weight, 100 billion stars. When he realized what that meant, he nearly spit out his coffee. But that red dot was just the beginning. The next day they found 5 more galaxies just like this. Turns out, these 6 massive galaxies are as old as the Milky Way itself. The entire research team was in disbelief. They were like, wait, what? These guys couldn't be that mature so early in time. Did we make a mistake? But nope. The James Webb Space Telescope, the new cool guy on the space block, just has some serious skills. It can see through dust clouds with its infrared vision and spot galaxies that were previously invisible. Move over Hubble. There's a new stargazer in town. But why is it shaking things up so much? Because this discovery affects our understanding of how galaxies formed. Let's try to explain. A long time ago, 13.8 billion years ago to be precise, our universe was born. It was chilling out for a while, and then it started to form the first galaxies. And these galaxies were full of gas and dust. Eventually, this gas started turning into stars. Some galaxies were more massive and had more stars, and some were lighter and had almost no stars at all. In any case, they all grew gradually. The stars in them were born slowly and smoothly. That's how our current models explain this. But these new observations from the James Webb Space Telescope show an unexpected surprise. Looks like, even in the early universe, our ancient friends had lots of stars. More than what we would ever expect. If that's the case, then these galaxies are like the overachievers of the universe. They skipped the small and gradual growth phase and went straight to being giant universe breakers. According to our current cosmological model, they shouldn't even exist. But they do, so it looks like after the Big Bang, the stars were forming much faster than we thought, which is pretty weird. This could mean that there's something missing in our understanding of the galaxy formation. As you can see, these universe breakers are really living up to their name, causing a potential total consensus among scientists. The universe was like, hey, I'm about to flip cosmology models upside down. But let's not jump to conclusions. There are many theories that could explain these mind-boggling discoveries without breaking the standard model. For example, maybe the light we're seeing isn't coming from stars at all, but from the swirling disks of doom around supermassive black holes. These colossal cosmic beasts can gobble up matter and spit out a dazzling light show. And James Webb Telescope's keen eye is picking up on these enigmatic accretion disks like never before. Or maybe these galaxies could be playing hide-and-seek with us. Maybe there's more to the story that we haven't seen yet. After all, the universe is vast and mysterious, and we've only just begun to scratch the surface. And whoa, we really need to slow down here. Before we even try to explain all this stuff, we need to confirm whether these ancient galaxies really are that old. Although even if they're actually just supermassive black holes, it still shows an astounding change. We'll have to wait about a year to find out. One thing's for sure, the James Webb Space Telescope has definitely taught us a valuable lesson. Expect the unexpected. And this is just the beginning of unexpected. Evolaba's team wasn't the only one who made such a huge breakthrough. There's also a team that claims that they've unlocked the secrets of the universe's past, and that's worth 2 Nobel Prizes. Move over James Webb Space Telescope, because this discovery came from an antenna that's smaller than a fridge and costs less than $5 million. Talk about space bargain hunting! The astronomers caught this signal that showed some surprises. It was coming from the earliest stars of our universe, back in the days when they were just beginning to twinkle. Say hi to our celestial ancestors again. Now, the signal was pretty weird. The temperatures were unusually low, and there was a pronounced wave that left astronomers scratching their heads. What could be causing all this? Well, there's a theory. Dark matter may have been at work, and if that's the case, then we can really be on the verge of a great discovery. Imagine you're looking at the night sky filled with stars, but there's something else there that you can't see. It's like an invisible cloak that covers the entire universe. Scientists call this mysterious stuff dark matter. Dark matter is like the ghost of our world. It doesn't emit, absorb, or reflect any light. We can't see it with telescopes or our eyes. That's why we call it dark matter. But if we can't detect it in any way, how do we know it exists? Because of its gravitational pull. One day we noticed that our understanding of how galaxies were created was incorrect. According to our calculations, they should have been some chaotic gas, but something held them together, turning them into spirals, like some kind of invisible glue. Then we thought, maybe this invisible glue really exists. If the moon was invisible, we would still suspect that it exists somewhere because its gravity affects the tides on Earth. This is also the case with dark matter. Its gravity influences the motion of galaxies and other cosmic objects. In fact, dark matter makes up a huge chunk of the universe, about 27% of it. Moreover, the normal matter we can see, like stars, planets, and galaxies, only make up about 5% of the universe. So even though we can't see dark matter, there's actually more of it in the universe than everything we can see. Scientists are still trying to figure out if dark matter exists and what it can be made of. Some theories suggest that it could be made up of exotic particles that are different from the particles that we're used to. Others think that it might be some kind of weird, undiscovered form of matter that doesn't interact with light at all. Anyway, it's an intriguing mystery, and if we ever confirm the existence of dark matter, our understanding of our world will change forever. So now you can understand why the excitement in the scientific community is palpable. If this discovery is confirmed, then we will get the first real proof of dark matter. This discovery may be even more important than the Big Bang itself because, as astronomers put it, we are made of star stuff, and so we are glimpsing at our origin. But of course, we still have to wait and explore all this in great detail. In science, one should never rush to conclusions. And while scientists study this stuff, we'll be here, on the edge of our seats waiting for the next space blockbuster to unfold. The universe never ceases to amaze us with its wonders. Who knew that such a small and humble antenna could unlock such cosmic secrets? It just goes to show that in the vastness of space, even the tiniest discoveries can have the biggest impact. Keep looking up, and who knows what other cosmic surprises are waiting to be uncovered. Imagine a still, frozen world. It's ancient, about 4.5 billion years old. It's barely heated by the rays of the sun and covered with a thick layer of ice. This world is smaller than our moon, but a bit larger than Pluto. Its name is Europa, the 6th satellite of Jupiter and one of the biggest moons in the solar system. But the coolest thing about this faraway place, it might host life. Astronomers consider Europa one of the most promising places in the solar system to search for new life forms. All because this moon has a huge saltwater ocean with a depth of 40 to 100 miles. Yes, it is hidden under a layer of ice that is estimated to be from 10 to 20 miles thick. But it is still potentially habitable. Astronomers claim that plumes of water erupt from cracks in the ice shell and release the contents of the moon's ocean into space. Of course, it's going to be challenging for any life-seeking missions to access such a deep environment. On the bright side, scientists already have some evidence that there are way shallower pools that probably lie much closer to the surface of the moon. They might be located even less than 1 mile under the ice. And there are two great things about this news. First of all, it boosts the odds of life existing on Europa. And secondly, if it's true, it can make it easier for future missions to find these life forms, if there are any. Interestingly, the new discovery about these shallow pools came about by sheer luck. The scientist leading the research, Riley Kohlberg, accidentally saw a presentation of his colleague, a planetary scientist. That scientist showed a picture of double ridges on the surface of Europa, and Kohlberg remembered that he had seen similar ridges on Earth. But while such formations are rare on our planet, they are way more numerous on Europa. The following studies suggested that the ridges on Jupiter's moon might be the result of a specific cycle, similar to that on Earth. In this cycle, liquid water freezes and then thaws inside an ice sheet, which is a rather high-pressure environment. This causes the sheet to move upward over and over again, creating a two-peaked structure. Or at least that's what happens on Earth. If the processes on Europa are similar, it can prove the presence of shallow waters on the satellite. Of course, the temperature, pressure, and chemistry are very different on Europa. And scientists don't know yet how the ice behaves there. That's why they can't understand how deep or large the water pockets are, or how long they need to refreeze. But what is more or less clear is that such under-ice environments on Europa are very likely to be protected from Jupiter's harsh radiation battering the satellite's surface, which in turn increases the chances of life existing on Europa. Now, can we get back to the fact that the ocean on Europa seems to be salty? Red streaks on the satellite's surface might have this color due to their chemical content. They're likely a frozen mixture of water and salts. This is quite unusual because such a composition doesn't match any known substance here on Earth. As for yellow spots on Europa's surface, those might be caused by the presence of sodium chloride. You know this substance as good old table salt. Scientists tried to recreate the conditions on Europa in a lab. They discovered that by combining water, table salt, freezing temperatures, and high pressure, they could get a new kind of solid crystal. This substance might exist both at the bottom of Europa's ocean and on the moon's surface. But besides this information, researchers are in the dark. Hopefully, we'll find the answers to some of these questions around 2030. That's when a mission called Europa Clipper, which is going to be launched by NASA, will probably reach Europa. The mission is going to have several close flybys and figure out if any form of life can exist on the moon. The European Space Agency's JUICE, which stands for the Jupiter Icy Moons Explorer, is going to visit Europa in the next couple of years too. But Europa isn't the only place in the solar system that might host or once hosted life. In 2003, Mars Express, a spacecraft launched by the European Space Agency, discovered methane in the atmosphere of Mars. On our planet, the biggest part of this gas in the atmosphere is produced by living creatures, for example by cattle digesting food. However, scientists think that methane was stable in the Martian atmosphere for about 300 years. And then, in 2006, the methane almost entirely vanished from the red planet, and it happened 600 times faster than researchers' models accounted for. The question, what or who generated the gas, and where did it go? Another Martian mystery is microbes that may be sleeping beneath the surface of Mars. There, they might have been protected from the harsh radiation coming from space for millions of years. Scientists simulated the conditions on Mars in a lab to check if it could possibly be true. And they were amazed to find out that bacteria could easily survive in such conditions for 280 million years. Which means that if life existed on Mars, we could find the evidence in the planet's subsurface by drilling into the Martian soil. Right now, there is no flowing water on Mars, and cells or spores would simply dry out. Plus, the surface temperature is similar to that of dry ice. In other words, the surface of the planet is deeply frozen, and still, there could be 6 types of bacteria and fungi living underground on the red planet. The most likely of them is nicknamed Conan the Bacterium due to its tough nature. Well, I guess time will show. Now let's move to Venus. In 2020, scientists announced that in the toxic Venusian atmosphere, there was something that might mean the existence of life. Unfortunately, scientists didn't have any evidence, since there was no chance to collect any microbe specimens or snap any pictures of extraterrestrial life. But they claimed that they had discovered a chemical called phosphine there, and it was a big deal. If it wasn't some previously unknown chemistry that was producing this gas, then there could be some kind of microbial life involved in the process. Phosphine is made up of 3 atoms of hydrogen and 1 atom of phosphorus. This gas is toxic to any terrestrial life form that needs oxygen, including us humans. On our planet, phosphine can be found in places with no or little oxygen, for example, marshes and swamps. The gas is created by complex mixtures of bacteria living there. It can also be produced industrially. Come to think of it, phosphine isn't supposed to be in Venus's atmosphere altogether. This gas needs precise pressure and temperature and tons of hydrogen to form. It wouldn't be all that surprising to find it on Saturn or Jupiter, famous gas giants. But on Venus, totally unexpected. There's no way phosphine can be naturally produced on this planet. Tiny amounts of it can be created during volcanic eruptions, lightning storms, minerals blown up to the surface, or meteorites entering Venus's atmosphere, but not as much as astronomers thought they had observed. And it had to make scientists suspicious, but they were too happy about their discovery. They probably thought it meant there could be life on Venus. But even if this gas was created by some mysterious organisms, it would be a big question how they survived on Venus. On our planet, some microbes can thrive in environments with an acidity of 5%, but no more. On Venus, though, clouds are almost entirely made of acid, containing more than 90% of sulfuric acid. The Venusian atmosphere is also 50 times as dry as the driest place on our home planet. And indeed, in 2022, thanks to better and more high-resolution telescopes, it was concluded that there was no phosphine in Venus's atmosphere. Or even if there was, it was a very small amount. So far, we need to look for signs of life further away from Earth.
Perhaps we've all stopped to think at one point about what it would be like to live on another planet. I know I've had days like that. Gotta get away. And maybe even interact with other types of creatures that already live somewhere else in space. These days, such ideas sound more like something from a science fiction book. But in the future, permanently changing your address to another planet might turn out to be mandatory. Think of the stars in our solar system as a battery. Billions of years from now, its energy will be gone. Without its light and warmth, life on Earth can't exist. When you think about it this way, we have to hope that future humans will have found some other place to live by then. Thankfully, there's good news. Recently, scientists at NASA have announced that they have found a new planet that might be able to support life. They call it TOI 700e. E is roughly the same size as Earth, and it's located in a region of space where scientists think water could exist in its liquid form, which is crucial for the development of life. This planet is not the only one, though. Close to it, there's another promising planet which they call TOI 700d, but this one is further away from its star. Because of the distance from the main source of light, Planet D lies in a special area called the conservative habitable zone. In simple terms, scientists aren't sure whether life might exist on this one, but they don't exclude such a possibility. Planet E is in the optimistic zone, which means that it's possible that it has water and even an atmosphere. Hey, at least we have some options. The two planets are in a solar system that's only 100 light-years away from Earth, which is considered pretty close in space terms. NASA found these planets by watching the light from the star and measuring how it moves when a planet passes in front of the star. This is the first time that NASA has found a solar system with multiple planets that could have life. So far, scientists have found over 5,000 exoplanets, and they think there could be at least 10,000 more. Specialists at NASA are looking into the ways to figure out if any of these planets could harbor life. But they also say we might find forms of life we don't expect to see, and that we should be open to other possibilities. That's because we only know about what life can be by looking at our own planet. Sure, everything sounds enticing so far, but don't pack your bags just yet. As appealing as these new planets might sound, there's still one problem: getting there. Scientists have been researching for decades how people can stay in space and thrive for long periods of time. And history tells us it's no easy project. Back in 1962, John Glenn became the first American to orbit our planet. To circle Earth a mere 3 times, he had to go through months of technical and physical preparations. These days, advanced technologies help us investigate Mars better, and scientists have figured out that there is water and materials on the red planet that may be useful to people. It has sparked the idea of sending people to Mars to live there, just to begin with. The first manned Mars mission is scheduled for the late 2030s or early 2040s, if everything goes well. The plan is for this to be a round trip, but even if NASA manages to plan everything well, the round-trip journey will still take about 500 days. It all depends on Mars and Earth's positions in their orbits around the Sun. One of the biggest problems with living on Mars is gravity. For starters, the astronauts will arrive at the red planet after months of living in microgravity. It means it could take them a lot of time to physically get in shape before they could start exploring. That's because living in microgravity conditions heavily affects the human body. It might mean loss of bone and muscle mass, as well as a shift in the normal movement of body fluids, which tend to go upward. This can lead to pressure on the eyes and even problems with people's eyesight. But Mars is right here, in our own solar system. What about planets that are light years away? The answer is still up for debate. It may sound cool to travel really fast, like at the speed of light. So far, scientists believe it's not possible. Sure, we may have been able to create airplanes that travel faster than sound, supersonic aircraft, but it's not the same. There's quite a difference, actually. Light is about 1 million times faster than sound. Traveling at the speed of light would mean we could go from Earth to the Moon in 1 second, or from Los Angeles to New York in less than the blink of an eye. But what stops us, though? Some say it's energy. It may be possible to make something go really fast, but it'll take a whole lot of energy. In this case, engineers will need to find new ways to make things move in space. Right now, rockets use fuel that is similar to the gasoline you use in your car. But that's not very efficient when it comes to space travel. Other ways to push a spacecraft include using electric or magnetic forces. One promising idea is using a solar sail, which is like a large thin sheet of plastic that can be pushed through space by sunlight. Some spacecraft have already used solar sails, and scientists think they could go up to about 10% of the speed of light. If other planets in our solar system turn out to be inhospitable, and we can't invent spaceships that move fast enough, we might still have a choice. Secret Option C. It was first proposed by a scientist who wrote an interesting study about a special type of planet. It suggests that we might not need spaceships to move around and escape problems on our own planet. We could use planets that are not orbiting a star. They're called rogue planets. Ooh. Instead of gravitating toward a star, these lonesome space objects simply drift alone through space, doing their own thing. Think about it this way. Moving to Mars is like moving to an already furnished house. Regardless of how nice it would be, you would still have to adapt to it. You'd have to get used to how much light gets in through the windows every day, and to climbing up and down the stairs to get to the living room. Moving to a rogue planet means we'd start from scratch, building our own house from the ground up, perfectly adapted to our needs. Free-floating planets are usually seen as cold, dark, and not suitable for life. But if they have underground resources, they can be useful. They offer a constant surface gravity, a lot of space, and resources. They can also provide water and protection from space radiation. If we become an advanced enough civilization, we might be able to control the planet and even create new types of energy. So the next question would be where we could find such a rogue planet. It's hard to know how many of these there are in the universe, but scientists have found a bunch of them in one region of the Milky Way galaxy. Some rogue planets have been kicked out of their own solar systems because they were bad. No, not really. It was because of gravity, while others might have formed on their own. Either way, we don't want rogue planets to get too close either, at least not in the near future. The chances of a rogue planet entering our solar system are extremely low. But if it did, it could mess things up for us. Depending on its size, a rogue space object might divert other planets off of their course around the Sun, which could alter their exposure to light and warmth. And if it crashes into the Earth, well then that would be a bad thing too.
In the heart of the galaxy, there lies a mysterious object, the likes of which no astronomer has ever seen. It streaks across the sky like a shooting star on caffeine. So, what is this mysterious blob, and how is it related to the black hole in the center of our galaxy? Let's find out. This thing is called X7. It's the mysterious blob that's been hanging around our galaxy's supermassive black hole for decades. Some even say it's been lurking around there for, like, hundreds of years. We know a few things about X7. For example, it weighs around 50 times as much as Earth. It may sound like a lot if you're an Earthling, but in space, that's like a tiny drop in the ocean. X7 is also moving pretty fast, at speeds of up to 700 miles per second. That's faster than you trying to catch the last slice of pizza before your roommate gets to it. But what in the world is this thing? A magic star we've never seen before? An extraterrestrial spaceship? Well, there are some theories connected to the blob's future tragic fate. Unfortunately, X7's days are numbered. Right now, it's on a 170-year-long elliptical orbit around the supermassive black hole at the center of the Milky Way. But it's not going to make it that far. Each year, it's spiraling closer and closer to the black hole. In just a few years, it will become spaghettified. Yes, that's a real scientific term. And finally get sucked in, never to be seen again. There are supermassive black holes in the centers of all galaxies, including our very own Milky Way. These black holes are so massive that they warp space-time, causing nearby stars to orbit around them at incredible speeds. They serve as cosmic vacuum cleaners that suck in anything and everything that comes close enough. The black hole in our galaxy is called the Sagittarius A star. Sounds like the name of a fancy Hollywood celebrity, doesn't it? But this celestial object is far more impressive than any mere mortal. It's about 4 million times more massive than our sun, which means it could probably eat our entire solar system for breakfast. But don't worry, these black holes may seem really scary, but in reality, they're too small to compete with an entire galaxy. They'll just suck in a couple of the nearest stars, and that's all. Also, Sagittarius A star doesn't seem to have a very good appetite. It's been observed to be pretty quiet lately, which is good news for us. But even if it were super greedy, it wouldn't pose any threat to us. This black hole is over 26,000 light years away. From Earth, we can see it in the Sagittarius constellation. In 2022, the Event Horizon Telescope collaboration released the first ever image of Sagittarius A star. It took years of collaboration and technology to capture this stunning image. And this is our second photo of a black hole in history. The first one was released in 2019, and it showed the supermassive black hole called M87 star. Yes, they both have star in their names. Don't try to make it make sense. Anyway, you may remember this photo as the first ever image of a black hole ever. It went crazy viral across the internet. And this black hole M87 star, located in the Messier 87 galaxy, is way scarier than Sagittarius A star. You thought 4 million solar masses is impressive? Then how about 2.5 billion solar masses? M87 is a real monster. It's also known for its powerful jets of plasma, which are so energetic that they extend thousands of light years from the black hole's center. If M87 were a superhero, it would be Iron Man, with his repulsor beams on full blast. Now technically, you can't take a photo of a black hole itself, since it's, well, black. No light can escape its grasp. But the glowing orange ring in this photo shows the matter surrounding Sagittarius A star. It's called the accretion disk, a swirling disk of hot gas that spirals the center, heating up to millions of degrees in the process. It's like a giant fiery vortex, but with no escape. And the shadow in the center indicates the black hole itself. Inside that shadow, there's an event horizon. The event horizon is the boundary around the black hole, beyond which nothing, not even light, can escape its gravitational pull. It's the point of no return, where the gravitational force is so strong that even the fastest object in the universe, light, can't escape. Once you cross the event horizon, you're doomed to fall toward the center of the black hole, where the laws of physics as we know them break down. And this is exactly the fate that awaits our unfortunate X7. Right now, the pure blob is getting stretched and yanked by powerful tidal forces. By the way, before it meets its untimely demise, X7 is expected to put on a bit of a show. Its closest approach to the black hole, called periastron, is projected to happen in 2036. And when it finally gets torn apart by the Sagittarius A star's gravitational forces, there may be some cool fireworks to see. But this is not the most important thing. The funny part is, X7's future end may help us finally understand what the heck even is this thing. A team of scientists have been studying how a strange blob orbits the black hole. And that's when they discovered that X7 has stretched to almost twice its initial length. And what does that mean? Well, it suggests that X7 is most likely made of debris ejected during a recent collision between two stars. Yep, you heard that right, a space car crash. Imagine this. Two stars fall in love and start circling each other for many years. After that, they finally merge together. At this moment, they eject tons of gas and dust. And perhaps this cosmic dance created our blob baby, X7. It's basically like the crumbs left on the table after a giant space feast. Something like this is actually pretty common, especially around black holes. It's like a galactic fender bender that sends debris flying everywhere. Actually, the universe is full of mystery blobs. They're called the G objects. No, they're not the G-men from Men in Black, but they're just as mysterious and elusive. These guys have been puzzling astronomers for more than 20 years. They look like gas clouds, but behave like stars. It's like they can't decide whether they want to be a cloud or a star. Come on, guys, make up your mind. G objects stretch out at the closest point to the central black hole, but emerge intact, like a rubber band that stretches but doesn't break. Scientists think that they're the stars that have merged together into one. And while doing that, they also produce a huge cloud of gas that hides the result from view. Kinda like when you're wearing a bulky sweater, so that no one knows that you've put on a few extra pounds. And then a study published in 2021 found that one of these objects, G2, was actually a molecular cloud concealing 3 baby stars. Talk about a plot twist. But X7 is the black sheep of the strange blob family. It's significantly different from the G objects, like the weird cousin you see once a year at family gatherings. Its evolution has been more dramatic. Also, it's not being held together by a mass lurking in its center. So what is it being held together by? Pixie dust? Magic? We need answers! That's why scientists believe that X7 isn't a G object itself, but debris left from it. Or maybe not. We have no idea. The possibilities are endless, and that's what makes astronomy so exciting. So let's keep our eyes on the skies and see what other strange objects are out there. Who knows? Maybe we'll discover another mystery blob, and this time it's going to be a spaceship. Now that would be awesome. When you look at the night sky, it seems like there's not much happening up there, and that the stars always twinkle at the same spot. For thousands of years, researchers followed the idea that the lights in the sky were unchanging. Sailors guided their ships using fixed stellar patterns. There are also the exact outlines of constellations we observe today, and astronomers identified them a long time ago. It seems impossible that one day we wake up and simply can't see some stars anymore. Or does it? A team of researchers at Vanishing and Appearing Sources during a Century of Observations, or VASCO, studied the sky to check how things with the stars are going. The astronomers got the data from Gaia, the European Space Agency, and compared the information from 70 years ago to that from today to see how the sky has changed. To test it right, they had to use both modern and old telescopes. And something really interesting happened up there. Over 700 stars from the old maps were missing. If one star disappears, multiple theories could work. But it's harder when hundreds of them vanished at the same time. Could it be that the data was wrong, or these stars were too faint to detect? Nope, they quickly eliminated this option because these stars had clearly been part of their earlier observations. So, the first thing that comes to mind when talking about how stars disappear is that they reached the point where they ended their lives. You can have the most massive stars of all, and we're talking about those that are way heavier than our sun, and they go through sudden changes as they get to the end, which we also call a supernova. It's a powerful explosion that later shines for many, many months, and it's still visible even across hundreds of millions of light years. But that's the point. You see the traces, unlike here. Could this be a failed supernova? That means maybe one of them collapsed but turned into a black hole and consumed the remains from the inside out without causing a powerful explosion. But no one's been mentioning any signs of a black hole being active anywhere near those stars. And what if the stars had become less visible because of dust or gas around them? This is something that can easily happen, as interstellar dust and gas do block our view of objects that are far away. But there were no traces of unusually high concentrations of dust or gas. Nothing destroyed them either. Researchers would have seen traces if something like that had happened. Plus, these missing stars were not all in the same area, which means there probably wasn't just one fatal thing that made them all disappear. Also, the stars were not at the same stage of their life. So it's not an option they were all accidentally close to their end. They weren't particularly old or young, and they were on different levels in size and brightness. At some moments, it even seemed these stars haven't vanished because of some natural events. Maybe it was something related to other civilizations that might be somewhere out there in space. Maybe that's one of the ways to look for them. We could stumble upon some secret civilizations from other planets if we carefully observed the behaviors of stars, especially those we can't explain. No one knows what exactly happened with the missing stars, and unfortunately, right now, all we have are these theories. But you have to admit, they're cool though. Maybe it's just some kind of optical afterglow caused by gamma-ray bursts, or maybe even fast radio bursts. Fast radio bursts are powerful pulses of radio waves. They can release more energy in a couple of thousandths of a second than our giant sun does in almost 100 years. We don't really understand how these energy eruptions work yet, so we don't know what they can do. But still, hundreds of stars at approximately the same time. There are between 100 to 400 billion stars in our galaxy, so we'll probably see some of them disappear too. Hopefully, we'll understand better why such things can happen. Of course, scientists are not sure about this number because we can't see all of the Milky Way stars from our home planet. Some are too faint, some are too far, or even hidden by dust or gas. But they assume these numbers based on the size, shape, and likely mass of the Milky Way. And out of billions of stars, there are a little over 9,000 of them we can see with the naked eye. If you want to see more, you need a good telescope that will reveal those fainter ones your eyes are unable to discern. Many of the stars we see in the night sky are probably not alive anymore. Stars are giant balls of gas that produce light and heat through nuclear fusion in their cores. However, stars also have a limited lifespan, and eventually, they run out of fuel and stop shining. When a star passes, it can either become a white dwarf, neutron star, or black hole, depending on its size. Scientists have discovered that some of the stars we see in the night sky are too old to still be shining. This means that they may have faded, but we are still seeing their light because it takes so long to reach us. Actually, we may be looking at the past when we look up at the stars. Check out all of the stars you can see with your bare eyes. They lie within about 4,000 light years of us. That means what we're seeing are stars that appeared 4,000 years ago. Most of the stars we know of exist within galaxies, which are massive collections of stars, gas, and dust held together by gravity. Still, there are large areas of empty space between galaxies too. And the question is, could they have any stars? It seems that these areas of space are not completely empty. There is still some gas and dust, as well as dark matter, which is a type of matter that we cannot see but we know exists because of its gravitational effects on other objects. Scientists have even discovered a few isolated stars in these areas of space. These stars didn't form there. They ended up there by accident, which means they have probably been ejected from their galaxies by gravitational forces or collisions with other objects. And there could be more of these stars than we realize, but they are simply too dim to be seen from Earth. Stars don't actually twinkle. It's more that we just see it like that from the Earth. It seems like they twinkle because of the turbulent atmosphere of our planet. The light from a star must pass through many layers of the atmosphere. Not every layer is equally dense, so this causes the light to slightly deflect and change in color and intensity. There's one star named Sirius that sometimes twinkles, sparkles, and flashes so much that some people even tend to report it as something extraterrestrial. This is because Sirius is very bright and is often low on the horizon, which means it experiences more of these special effects of the Earth's atmosphere. When in space, astronomers and astronauts who observe stars from there don't see them twinkling. Hey, want to hear something cool? Me, you, your friends, the rest of humanity, we're all made of stardust. The elements that make up human bodies and all life on Earth were formed inside stars. The building blocks of life, such as carbon, nitrogen, and oxygen, were created inside stars and were eventually released into space when the stars were gone. These elements then became part of new stars, planets, and eventually life on Earth. The iron in our blood was created in the cores of supernovas, which are massive explosions that occur when stars fade. Some say that even the calcium in our teeth and bones is likely to come from exploding stars. The oxygen in our lungs was created in the cores of massive stars before being released into space through supernovas.
The universe is a big, mysterious, and ever-changing place. But just like we have baby photos that show how we looked when we were little, scientists also have the Oscars of science for a picture that shows the entire universe when it was just a baby. Scientists achieved this fantastic feat using NASA's Wilkinson Microwave Anisotropy Probe. To take this picture, they built a super cool satellite, launched it into space, and collected massive amounts of data about the universe. This image turned out to be a cosmic treasure trove. It helped answer some of the universe's biggest questions, but also revealed a few new mysteries. This groundbreaking data confirmed the standard model of cosmology and told us that our universe is around 13.7 billion years old. Plus, it showed us that the elements in our regular periodic table make up only a tiny fraction of the universe's recipe. To be honest, this is not quite a photo in the usual sense. Of course, we cannot actually photograph what happened so long ago. The picture we're talking about is called the Cosmic Microwave Background, or CMB for short. Now, the CMB is like a faint glowing light that fills up the entire universe in every direction. These clues that can help us understand how the universe evolved into what it is today. CMB is a super cool glow that fills up the entire universe. You see, when you look through a regular telescope, the space between stars and galaxies seems pretty dark. But with an amazing radio telescope, we can actually detect that this empty, dark space is filled with a super faint and even glow. This glow is all around us, and it's not coming from any star or galaxy. This is the cosmic microwave background, and it's strongest in the microwave part of the radio spectrum. The CMB is a frozen treasure, super chilly at around minus 455 degrees Fahrenheit. Bruh, that's colder than any winter you've experienced. This ancient light formed about 380,000 years after the Big Bang, which happened around 14 billion years ago. So we're looking way back in time. In the beginning, the universe was like a thick fog of incredibly hot plasma. It was almost 500 million degrees Fahrenheit. It was so hot that atoms couldn't even exist yet, only wild electrons and protons bouncing around like crazy. Because of this super hot fog, any light that tried to travel got scattered by those mischievous electrons. It was basically like trying to see through a foggy car windshield. But then, the universe started expanding in all directions, just like a cosmic balloon getting bigger and bigger. And it's still expanding today. As the universe did that, it began to cool down. When it turned 380,000 years old, it finally cooled enough for electrons and protons to come together. These tiny particles started to combine, forming mostly hydrogen atoms. When that happened, the universe finally became transparent, like a clear window. The moment of this magical transition is called the recombination epoch. Once the foggy era ended, the light could travel freely. The universe became like a vast playground for light to bounce around and explore. And, as you know, light has a certain speed, 186,000 miles per second to be specific. And it takes some time for light from distant places to reach us. So, in other words, the CMB is the oldest light in the universe. It's like a capture from a moment when the universe just started to become clear and transparent. As this light traveled through space, it went through all sorts of adventures, like the formation of stars and galaxies. Along the way, it lost some energy and transformed into microwaves, which our eyes can't see, and that can be detected only with special tools. Also, there are some tricky things that can mess with the data. For example, galaxy clusters. These are big groups of galaxies hanging out together in space. When the ancient light from the CMB travels across the universe, it encounters these groups, and these sneaky clusters try to leave their marks on the CMB. They distort the patterns in the ancient glow, like smudging the ink in the important ancient book. That's why scientists have to invent techniques and supercomputers to help clean up this mess and decode everything properly. Due to all this, the CMB isn't perfectly smooth. It has a few little bumps and patterns. These weird patterns make it unique, kind of like the universe's fingerprint. Scientists have been using amazing tools like the Cosmic Background Explorer and Wilkinson Microwave Anisotropy Probe to study these patterns. The COBE, our cosmic camera, took the first ever map of the sky in microwaves from 1989 to 1993. Why do we study it? Well, because the CMB can help us learn so much about the early universe. Stuff like how it expanded, how much normal matter and mysterious dark matter it had, and even the overall shape of the universe, and much more. We're basically playing detective with the cosmos, trying to decode the mysteries of our world by little clues and prints. What are the results? Well, awesome tools like the Wilkinson Microwave Anisotropy Probe helped us to learn more incredible facts. For example, we found out that we can actually only see 5% of the universe. Imagine the universe as a cosmic pie. Scientists learned that 68% of it is made up of something called dark energy, and 27% is dark matter. Only a tiny 5% is made of normal matter, the one that we, humans, can see. So, most of the universe is like this hidden realm we can't even imagine. We also found out what happened in the beginning of times. Picture the universe right after the Big Bang. It was so tiny, way smaller than a proton. Everything we see today was crammed into this itsy-bitsy space. The rules of quantum mechanics, which let weird and wild things happen, were in full swing back then. Matter and energy were like playful adventurers, borrowing from the future and disappearing into nothingness. Then, cosmic inflation happened, and the universe suddenly expanded like popcorn on a cosmic scale. It became a trillion times bigger than it was, creating waves of gravitational chaos everywhere. Some gravitational waves filled the baby universe like a sea, and their patterns left unique fingerprints on the CMB light. And all that learned thanks to the pictures of the CMB. Anyway, NASA has this awesome plan to study the universe's baby picture. They're going to use a really cool observatory called Kuiper, which stands for Primordial Inflation Polarization Explorer. Imagine Kuiper as a special space balloon that's going to fly up high in the sky from a place called Fort Sumner in New Mexico. It has two powerful telescopes that sit in a hot tub-sized container filled with liquid helium. This liquid helium is super cold at around -452 degrees Fahrenheit. But Kuiper loves the chill because it's extremely sensitive. What is its mission? To learn all about the early days of the universe, right from its first baby picture. When Kuiper is up there, it's going to look very carefully at the CMB, trying to find some hidden patterns that hold the secrets of how the universe grew and changed over time. This spy with a magnifying glass will be examining 85% of the sky. Kuiper's launch is scheduled for late September. You can even watch the exciting balloon filling action live on the Columbia Scientific Balloon Facility website. It's going to be out of this world fun. So the cosmic microwave background is like a time-traveling storyteller, giving us valuable clues about the universe's incredible past. Isn't that awesome? Space is full of surprises, and there's so much more to discover. Keep your eyes on the stars, and who knows?